So then we can make a start. Okay, it says I can hear you. Okay, perfect. Okay, great. Okay. Yeah, good. I can. Every 10 seconds delay, we can. All right, so everyone's now linked to the channel, so you can text us and ask your question, and we can send you back the answers. All right. Okay, so thank you. Okay, we are going to start our full-day workshop, and welcome everybody for coming. Great to see you. I almost recognize all the faces here because you had a module with me. That's perfect. And a warm welcome to the those who joined online. Yeah, thank you very much. Great to have you. And okay. So from prompt to the agent, yeah, your first intelligent AI system, yeah? So think about this title seriously, because we expect all of you at 5 p.m. today to build your own AI-based system, yeah? Multi-agent system. So your AI is beyond the LLM. You can do something, some action with the agent that you are building, yeah? Okay, so this is the co-curriculum activity, so there is no marks involved, yeah? So just relax and enjoy. So this is the steps that you are taking for yourself, your future, your CV, and your career, yeah? All right, so before we go through the teaching material, let me introduce the brilliant people here that were involved in organization of this workshop. So to be honest with you, these are the superheroes of today's workshop. They have done everything, and they spend all the effort for you to come and teach you something new. So I think you don't realize how much effort all of us put into this workshop to make it happen, yeah? From the applying for the fundings a couple of months ago, writing the proposal, yeah? And to the building our self-hosted LLM that we implemented on the university cluster. So we will share the API keys with you so you can use the LLM and integrate it into your system today, right? And also, we will learn about many other things. Okay, so we start with Reza. Reza is here. Reza, where are you? Can you stand up, please, and shake hands? Yeah, he's Reza. And then next one, Khashayar. Can you stand? Yeah, Khashayar is there. Okay, next one, Ali. Ali is busy with the registration. Yeah, and then our shining star today, Daniel, yeah, who helped a lot in every aspect of this organization. Yeah, thank you very much. And without your effort, we couldn't make this workshop happen. So these guys are around during the workshop, yeah? So you can ask your questions and go beyond, discuss the idea that you have about the AI and your final projects, right? So we are here to help you, to support you, yeah? So today, please ask questions. Please do make mistakes. Please build something, yeah? New, right? So, and this is the main purpose of this workshop. Okay, let's move on. As discussed, initially we wanted to have 2 channels on Teams and YouTube. We got some technical difficulty. We call IT to sort it out, but anyway, we finally decided to move on 1 channel that is easier for us to handle as well, right? So if you are not already, please go to the YouTube go to the Learning Plus to date, and go to the live. So you will see these slides, the view of different cameras here, the screens, and you can ask your question in the chat box, and we can share the link with you. So I give you 1 minute to do this. So the good thing regarding this type of streaming, so you will already have the whole previous and now recording now, so you can just scroll between the previous slides if you want to double check something, or if you want to see other content that we previously discussed. Okay, all good to go? Yeah? Okay. Perfect. All right, AI engineering, right? So that's a new title that you can see everywhere, right, nowadays. So AI is everywhere nowadays. So it's going to change every aspect of our life, change our future, change our job, and also we have, so for this reason, we need to learn about it deeper, right? So if you remember, for example, 1 year ago, 2 years ago, so you got many jobs posted on the LinkedIn that they were hiring the software developer, right? But today, this not exist anymore, right? Because nobody's interested in software developer anymore, right? So see AI, how it's influencing the job market, right? So now AI engineer is trend, so everybody is is recruiting AI engineer, right? So if you quickly go to the job search websites, right, you can see the job engineer, the AI engineer salaries starting from 40, 43 to 70, or if you are in the senior level, you can get up to 100K per year. That's exciting, yeah? Okay, so, and then I think this is the reason that you are here, I assume, yeah? To take a small step in this direction, right? And to implement the project that you have been waiting to start, but it's never happened, and you didn't know how, right? So we are starting small steps in this direction of the AI engineer, and hopefully you find it helpful at the end. Okay, so let's talk a little bit more about the AI engineering, so what that is and why it's so important, right? So you are all familiar, yeah, with the software engineering, so you can easily download the data set, clean the data set, and do the low-level feature extraction, apply different machine learning, and compare them. Yeah, this is a typical final year project, right? You're also familiar with the machine learning and how to use LLM like ChatGPT that provides information. Yeah. So, how about the system thinking and action? But if you combine all of them and apply the decision making as well into this, right? So you can build something that can do a job online for you rather than just providing the information like ChatGPT, right? So you see many agents that they can create a video for you, right? Just by simply scripting, yeah, create a video for me about this, yeah, and many other agents, right? So these agents are implemented, right, by developing several tools that you see here, by implementing the MCPs, RAGs, and using different API and tools, right, that we connect all them together in the right order, and then we can do some action. So the agent can do some action, right? So that's the difference between agent and the simple LLM, large language model, yeah? Today, to be honest, that's going to be fun today because the organization team already implemented all the required code and exercises with the solution are available on the GitHub, right? We will share the link shortly. This is public. And then there is a good README there. You can go through the README step by step together. We can build our stuff, right? All right, so have you all done the yeah? Everybody done? Yeah? Great job. Thank you very much. So we can move forward. So briefly about what we learned today, right? Okay, so we do all this implementation in Python, right? So you're all familiar with Python, right? So we built, we develop an internal large language model. We set it up on the university cluster. We share the API key for you, right? So that's free of charge. You don't have to pay for this. It's very responsive, very nice, so you can try your method. And also, you will build a UI, user interface, yeah, that allows you to chat or communicate with the LLM that you already have, right? So you will learn something about the Streamlit as well. So you will start to create a first agent in the beginning, right? It's a robotics agent, and then the chef agent. So it's getting more and more complex. And at the end, we try to connect this agent together, right, to build a multi-agent system, right? So this system can receive the input from the users through the chatbot that you will develop in a Streamlit, yeah? And then through the interaction between the agents, right, they can do the job and return the answer or what you ask for. In more detail, is here. I already shared the picture. So I have 4 more minutes to finish my session. So we will have lunch break at 1 p.m. outside here, and we will have the second coffee break at 4, yeah? And the most important thing is the final challenge that you will experience at the end of today at 5 p.m., right? So once you learn about all these technical things, about the MCP, about the RAG, about the UI development, yeah, we will give you a challenge to go through, and you should use whatever tool that you know, yeah. You can use our source code, or you can search online and try to do this job, yeah. This is the challenge. We will have the winner for this challenge that we will announce after you submit it. We quickly evaluate your submission and result, and then announce the winner, right? And finally, so we will finish everything at 6, hopefully, or a little bit longer. And finally, after we finish, yeah. No, it's the integration of the same material that you will learn, right? The source code will be available, yeah? And finally, we will provide a certificate of attendance to you after we finish and you sign out from the course. And we send it to you by email, right? One by one. Okay. So I think that's about it. So that's our GitHub repository and also Discord if you want to. We plan to run our future events through the Discord that is more efficient. But this is the GitHub repository that we have. So Daniel, could you please share the GitHub repository on the YouTube text, yeah? So you will receive the GitHub chat, GitHub through the YouTube chat. This is the link. So let me check if I have something else to discuss. Yeah. Yeah, that's about it. So this is the section. Let's start with some theoretical part. So this course has been organized as follows. So we briefly introduce some theoretical aspect of the agentic AI first, and then we jump into the implementation straight away from the GitHub repository that we provided. Yeah? Yeah, so I invite Reza to start with the introduction to agentic AI, and then we continue with the other speakers. Yeah, thank you very much. I use PC.
Thank you very much, Doctor.
Thank you.
So, hope you're all enjoying your time. How's it going? Good? Okay, interesting? All right. So, make sure you're all joining the Discord channel and the YouTube one. So, you will have access. We're going to share step by step some contents over the channels. And so, I'm going to give you a moment to have a time. Make sure you all have access to both channels. So I think there is a link there is a channel in Discord named announcement. You can get access to the GitHub, this link there as well. In the announcement channel in Discord, you can figure out the GitHub access. You can fork the repository or you can clone it. Okay, I would suggest you fork it because at the end of session, we have a challenge. We're going to ask you to fork the channel and then submit your developed code in the repository. And then we can check your submission. There is another way, but so let's move on to agentic AI. So, as you may know, it's a very new concept in artificial intelligence. It's not now. It just emerged 2-3 years as an agentic AI. But first, before start talking about agentic AI, we need to know what is large language model or what is language model, right? So, can you speak up louder? Yeah, thank you. Sure. Maybe I just need to. I see, but I just need to move it on top. Now it's better? Screen gone.
Yeah. Screen.
It's fine.
It's fine.
Yeah. So yes, we need to know first what is large language model, because at the very heart of the agentic AI we have large language model. Okay, so maybe nowadays everyone, anytime you're talking about LLM, first things come to your mind is AI, machine learning, or deep learning, these sort of things, right? But what is exactly LLM is? Do you have any idea? Can you share with us? Yes.
It's like a big data set.
Mm-hmm.
You ask some questions, and the list of the memory of data set is counted.
Mm-hmm. Data set. Okay. Any other idea?
Transformer-based neural network which generates text, and it has self-attention and multi-attention head and neck.
Very nice. Very good. Any other idea? No? That's good to start with, actually. But yes, deep down, an LLM model is a large language model with a big neural networks architecture, like transformer-based architecture. Look, it's not a thing just to start today or last year or in 5 years. It's been a long research been developed about language models. And we should start from text predictions, like, for example, you have a chain of words, and then you're going to predict the next. That was very beginning research about large language model. But nowadays, the contemporary models like GPT-4, Sonnet, Gemini, or Llama, or any other models you're facing these days, they are mainly based on transformer models, which is a deep learning model. Right? So let's see, how does it work? Simply saying, we have, for example, a sentence, which is incomplete sentence, like the capital of France is, so we all as a human know the capital of France obviously is Paris. But how a large language model can predict that. So let's see, by a transformer model, it can predict the output token, which is Paris. But how these things happening deep down? So simply saying, it looks very complicated, but it's not that simple. So what we need to do, computer doesn't understand words. We need to convert the words to some understandable form of information for computers. Like, for example, we convert the words to the integer values. Like you can see, like tokens here. For example, D will get the 791, and the rest will have another integer value. And then we're looking for the last one. We're going to predict the last one. So what's happening, we have another steps in the LLM models, which is embedding, word embedding, right? Which is nothing, just vectorize the contents, the information we have, and we're gonna vectorize each word to one vector with with a fixed length of dimensions, like 4,906 and 4,096 dimension of the vector. So we don't want to be very technical, but this is something at least we should know. Okay, how these things happening inside the LLM model. So this length is not fixed for all models. It can be different based on the models, based on the weight they have. And the next step is a transformer model. At least, because they are large language model, they're going to come up with large layer of transformer. The higher layer you have, the deeper your network is, right? So a transformer model working based on the self-attention model, okay? If you want to have a better understanding about this section, I refer you to two different papers. One is Word2Vec, about vectorization. Another one is Attention is All You Need. These are two papers which you must have read, right? So what's happening now at the end of the transformer model, you come up with a prediction, right? So based on the input information, based on the sequence of the data you have, your model come up with different probability level. For example, it can come up, say, Lyon, it can come up, say, Berlin or Paris, but different probability. And you will take the highest probability as your result. Here, like, Paris is the capital of France. This is the simplest way I could explain to you how LLM model could work in like architectural way. Any question about this slide? Okay, that's good. So, yes, we were talking about agents, right? Then we jumped to LLM model, which you said is the very central point of an agent. Okay. But what is the difference between an LLM call or LLM process, the process happening in LLM or in the agent? This is very important to understand how this process, what is the difference actually? How these things happening in these two different, not two different, actually, two different architecture, I can say. So, if you have LLM model, what's happening is you will have only one input or sequence of input, but you have one input, one output. But in agent form, in agent architecture, it's not like input, output. You give a goal to your agent, and it pursue the goal and come up with the result at the end. Okay, so That's the main difference. That's the first difference between these two. The second part is the process, how the process is happening. Again, I told you, we have one input and output in LLM call, but in agent, we're going to have a loop of actions. It comes from observation, plan, act, or plan, act, observation. It depends where you start from. Okay? And this is repeating to the time you reach the final goal, which is your answer. Okay? So we will talk about this in depth and with different patterns, with different models today. So obviously, LLM model does not have tool. What is tool? We're going to talk about it. But agents comes with some tools like API to get access to the other softwares, to the other components, to database, to code, or web crawling, or any other tools. It depends on the application. It depends on the agent you're running. Again, LLM doesn't come with memory. It's not. It's stateless. But agentic AI comes with different sort of memories: episodic memory, short-term memory, and long-term one. And so, I mean, it has its own benefits having memory. It can memorize, it can retrieve that information from the memory and use it for the next prompt. And yes, LLM drives by the user, but agents, it has some level of autonomy and it can drive itself. So, simply saying, the main difference between LLM and agent is LLM only responds to your call, but agent acts. Okay, you need to memorize this term. LLM response, agent act. Thank you very much. So bear in mind these terms, and we're going to move on to the next slide. I'm going to explain it in a different way. Okay, I'm trying to explain the difference, the agentic AI, with different slides to make it clear, more clear for you, from different point of view.
Doesn't LLM have memory? For example, if I have chatted something else, it does remember, doesn't it?
Look, the agent, the LLM you're working on now, for example, you're working with ChatGPT. ChatGPT is not LLM, pure LLM. It's agent now, okay? LLM is just, I mean, you will create LLM today. You will see. You have only one LLM and then give it a prompt and give you a response. So that's LLM. But GPT, while you're chatting, is not LLM. It's an agent. You're talking to agents nowadays. They have memory to give you answer. So, yes. What makes a system agent? Again, having autonomy, right? Autonomy means it can make decision without human input at every steps, right? So it means it can, you create architecture for an agent, and it has autonomy to come up with different flow, right? It has this privilege to use tools, okay? And like calling an API, run a code, or query database. Again, it can come up with a memory to remember past interactions and contexts, and it is goal or task oriented. So, yes, the more of these properties the system has, the more agentic it is. Okay. Any question about this slide? Clear? So, another way we can represent agentic AI or AI agents is layer-based. Okay, we will have four main layers. Perception layer, is a layer that the agent interacts with the environment, with the user. If the case is just interacting with only user, if it's a robot, the environment is a bit different, right? If it's a web agent, it's different. So it comes with the perception in the environment, and then reasoning. It depends on the large language model you're using. The reasoning might be different. The planning the pattern you are using for reasoning also have an effect on your reasoning or LLM layer, and the tools you are using and memory. So they all have, they all in the same loop. They have the flow is working in the loop, and they have interaction. They have interconnection. There is an interconnection between layers as well, right? So again, this is the architectural design of the most popular pattern of an agent, which we call it React. React comes from reasoning and act. Okay, so I'll give you a moment to take a look at this and come up with your understanding. What you see in this architecture first we have plan. Next, we have act. Third, observation. Fourth, reflection. But at the very heart of this agent, we have LLM reasoning. So without LLM model, which do the reasoning, which is the kind of brain of this system, this agent won't perform any task, right? So this is the main part that orchestrates the agent. So what's happening is, you remember the loop we were talking, 4 layers and the loop, interconnections. So what's happening, we have a plan. A plan can start from a prompt, then goes to the LLM. LLM based on the prompt and the requirements do act, okay? If it does need act, act is like, we said, LLM, response, agent, act, okay? Agent acts based on the 2 available tools, which you define for the LLM, right? So, based on the, you will see what is MCP, actually. We're going to talk about MCP, which is the very important part of acting. So, act based on the tools. Where is the tools? Tools are available mainly in MCP, in a professional way of using them. So, after doing act, you have some results, which you will observe the result, and then LLM check out the result, and you will have to reflect. If the answer is the one that you're looking for, you will say, mark it as a done. If not, again, this process, staying in the loop to reach out the final goal. Clear? Okay, very good. So, what we have learned so far, first of all, we learned what is LLM, right? What is the difference between LLM and an AI agent, and what make a system agentic, and the React architectural loop. Done?
Should we introduce the next?
Yeah, yes, please. Yeah.
Okay, yeah. Thank you very much, Reza,
You're welcome.
for your presentation.
Sure.
All right, so thank you.
Thank you.
So guys, just to briefly recap what we have learned so far, right? So that diagram that Reza presented is very helpful, right? So you can build your agent, yeah, but the heart of the agent is like LLM, large language model, right? So we provide it today, right? Daniel will tell us how to integrate it into your Python code, right? So the LLM will interacting with different tools, yeah, in order to make an autonomous decision, yeah, based on the user input, right? So whatever you say to the LLM think about it and make a decision what action to pick, yeah, or take, and then reevaluate the action and then show the answer to the user. So LLM, as Reza said, is different from the agent, but the heart of your agent that you're building now, right, is the LLM. Okay? So we learned briefly about the differences that we just discussed, and about the future of the agentic AI, and about the architecture of the agent that we are building today. Okay, so let's let's move on. So shortly we will start telling you how to communicate with the LLMs, how to send and receive the text in Python with LLM, right? So how to create, in the rest of the workshop, how to create a UI in order to serve as a interface between you and the LLM to send and receive, right? The text or prompts, right? So and a completely new topic, what is the system prompts, right? So what you have to consider when you're prompting, you have to make some assumption for your LLM to say, okay, you are now can serve as a teacher, you are now can serve as a student or engineer or whatever, right? So you will see the way that your LLM responds to you is completely different, right? So we categorize this topic as a system engineer, so we will learn about it. Khashayar will tell us what that is. And I believe the most important part, presentation in this workshop will be presented by Khashayar here about the MCP, what are the MCPs, how to use it, how to integrate it into your code, and how enable it to interact with your LLM in order to make a decision, right? And finally, we go beyond designing on one agent only. So we create a multiple agent. We try to connect them together and create a multi-agent system, right? So that's the plan today. So I invite Ali. Ali is running 3 mentees over today. So yeah, please.
Yeah, hello everyone. So now it's the time for Menti. We want to have some interactive feedback from you. Please go to menti.com, use the code or scan the QR code. And if all of you just scanned and are in Menti, I can go to next slide. Yep. So now we are going to the next question.
So guys, your answers helping us to know how to, if you need to go through more detail, yeah, to clarify, and if we need to provide further information and detail for better understanding.
Just a few more feedbacks.
Yeah,
Currently
if
we have
you could please, all
36.
of you, 49, answer the semantic. So since the online attendee is receiving this with like 10 seconds.
Yeah.
Yeah, please hold on for longer. Thank you.
Any more feedback? Or yeah. think it's so now let's go to the next slide. Which topic need more explanation, do you think? So these feedbacks really helps us to improve the rest of the workshop. The topics that currently we have here: AI agents, Python LLM requests, Streamlit, prompt design, and other. I think we can have a few more response and 38. Okay, now let's go to the
So that's an interesting, to be honest, interesting result, because most of you believe that you need to learn about the Python and integration with LLM, right? However, the less of you are interested in the AI agent, because this is the next step, right? Once you have learned about it, right, we repeat this Menti, and I hope to see more of you will focus on the AI, yeah? Because this is the next 8 steps of the LLM integration.
okay, and the last one. Okay, thank you, everybody. Now we are going to continue the workshop.
Arya, thank you very much. That was very helpful to see which aspect of the workshop we need to focus on more. So let's continue with the coding exercise. So in here, is this working? Okay, good. So that's the exciting part. So it's about the starting integration of the LLM with the Python and send and receive the data, and then in the next step through the AI, right? So Daniel is here to give us very quickly explain how to integrate it and how many methods that we have already, how to use our internal LLM on the university clusters, and how to use the online resources, APIs that we have. So, and then we go through the implementation after that. Thank you. Yeah, Daniel, please.
Thank you.
And to you.
So, hello everybody, I'm Daniel, whatever you like. We will just now jump into the coding and we will start the exciting part of this event. So, no worries. If you have any question, just raise your hand. If I can help you, or our friends will come to your system and help you with the issues that you have. That's it. So, just a quick intro about the LLMs and about the companies. We have two kinds of LLMs. Some of them are open source, which in the world of the AI, they call it open weight. And some of them are closed, and you should to pay to them to use that model. You can see here the OpenAI's model's name mostly are GPT. They call it GPT. Anthropic uses the cloud name. Google have two kinds of model. Gemini, which we have, and if you need to use the Gemini, you need to pay to them to get the API and to get the access. But they just released the Gemma, which is free to use the model, and the model is available. You can use it in your local systems. And for the Meta, it's Llama, and for the Alibaba, it's Qwen. That's it from this slide. I will move to the next slide. So, in this event, in this workshop, we will use two LLM models. One of them implemented on the university's server, which have 800 GPU. It's implemented by my friends, which is really exciting thing. We implemented Qwen on the university's PCs and the servers, and we will provide you an API key, and you will use that. The next option, which we will have, if in the case our local server have any problem, or in the last session, in the 5th session, we will use the Google one. And for that, I need all you to go to this website. Just please go with me, and we need to get the API. You all need to be logging with your Google account, and we will go to this website. Just go to this website, ai.dev, and you will be available to see the dashboard of the all AIs which Google provided for us. Yep.
Please repeat the website.
ai.dev, or you can search on the Google AI Studio, and you can go to that. And you can get started, and you will be in the same place. We all fine with this, yeah? Okay. In here, just go to the Get API key. And create an API key. If you don't have any project in here, in the process of all dashboards in all the API systems, even in the OpenAI or any other company's dashboards, you need to create a project for all the APIs which you're getting from that system or from that dashboard. So in here, you can come here and import your project or create your project. I think you don't have any project until now. Just create a project, put any name you want. It's not important for us. It's just for your, if you come back to this dashboard, you need to know which project's API is working and which project's API costs you and how much you use that. It's only for that. It's not important for us. Okay? We will use this Gemini. We will use the Gemini's 2.5 Lite flashlight, and it's free to use. They have limits on this API, but this limit is more than our usage, and it will be fine. You will not pay anything to the Google. Don't worry about it. So after you create your project, yeah, if you have it, you can use. Feel free to use. And you can name it anything you want. I will just put it AI event, just to be recognizable. And create the key. And please, if you are in the live, just don't use our API key. Just get your own, because we will get in the problem. Yep. You have a problem with it. Okay, could you please? Okay, I will be, yeah, don't worry. Could you help them?
Yeah. So we are here to help on this.
Okay, touch. Okay, this is our API key. Just keep it in the safe place. We will use that. Do you have any questions? I will show you again. Don't worry about it. We will go to the AI.dev.
Make sure you're keeping the key somewhere safe because you won't be able to retrieve the code again. So
Yeah, I will. Yeah, that's important part. Thank you, Reza. You will not be able to get access again to that key. Just copy paste it and keep it on a safe place. Keep it on your Visual Studio. Keep it on, I don't know, everywhere you want. And don't share it with anyone.
if you forget that key, you need to create new one.
Yeah. When you go to the AI.dev or aistudio.google.com, you will come to the Get API key on the left side in the sidebar. And when you click that, you will see the API keys page. And then create the API key, put your name, put any name you want, and put any project you want, or even create a project, and then create a key. And you will get your key. This is your key, which you will use it. And just make sure you will keep it in the safe place. When everybody are done with this part, we will move on to our local interesting LLM.
So once you're ready, just tell us if you manage to get the API key, all of you? Yes, sir. Yeah?
Everybody's fine.
Okay, perfect. So that's the, yeah, please. So that's the our backup option. Yeah, you already have the key in case, because sometimes we try to connect to the server all at the same time, we get a problem. So we already have the backup key, right? So you just copy and paste the key that you just downloaded. Yeah, please go on.
Yeah. Okay, we will move on to the local service. Our local service is implemented on your codes. You don't need anything accept the API key. And for the API key, all of you will use the same API key, which I will share it now in the YouTube's comment. And also we will share it on the Discord. Okay? Just get this key, please. Yeah, for the local service, I will share you an API key. We all use the same key. Yeah, just go to our YouTubes and be on our live page, and I will share it on your comment.
You don't have to be university network, which you already connected, right? We just share another key, which is for the local server.
من دیسکوردو اینجا ندارم، لطفا خودت چه. نه یوتیوب نمیذاره بیشتر از این، خیلی طولانیه، نمیذاره این کامنت رو بزنم. توی تیمز و توی دیسکورد براشون شیر تیمز نه یه دقیقه وایس. Yeah, we have a limit on the YouTube account for the comment characters, and I couldn't share that in there. I will show you when we will be clone our repository. Yeah, don't worry about it. Okay. Let's go to our repo and clone it in our VS Code. Just if you are fine with other application, you can use it. Just feel free to use. But if you are not familiar with any other one, we will use the VS Code. Just be sure you have in the university's computer, we all have the Visual Code Studio, and we will use that. So we will open the VS Code, Visual Studio Code. And you will all have our repos link. Rezan Khashaya, could you please create the one text file with only the API key and put it in our repo, just a quick, so I can open that. I don't want to open our main Python code. Just put it on the repo. Yeah. I will be waiting until you are done with that, and I will show everybody. So just for now, make sure you all have our repos link, which I already shared in the YouTube. Done. Yeah, thank you. So, okay. So in the VS Code, in the Visual Studio Code, you will see this page. We want to clone our repository. The clone means you will copy our repository, our whole repository and our whole codes to your own local computer. And then you can edit it and you can run the codes. You can, even if there is any issue on the code, you can edit that code and you can send it back to our repo and we will check that. So just click on the repository, or if you are fine with the cloning, just do it. I will go slowly to everybody know about the cloning process. Click on the clone repository, and you are now need to be copy paste your repos link in here. We have the link in the chat, in the Teams, and we share it everywhere with you. When you are done with this part, just click Enter, and then you can select any folder you want, any folder you are fine with it. We just go to the desktop and create a new folder, name it anything you want. I will call it AI Agent Events, and I will select as a repository destination. This part might be a little bit tricky. Could you please help him to, because I cannot go back, yeah? So, okay. So in here, I will come. Just don't worry about it. In here, you need to be logged in with your GitHub account and make sure the VS Code have your GitHub account. When you see these options, you can just click on the open, and if you want it to be, if you have your GitHub account, if you logged in your GitHub account on the VS Code, so you will be fine. If it asks you to log in your GitHub, just click on the open in the browser and just log in with your GitHub account, and then come back to the VS Code and you will see your repository. Is everybody fine with up to here? It's really important part. When we all are done and when you see this page, just let us know. Everything is fine. Does anybody have any problem? can we start our process?
Okay, that's good. Goes to the link.
Okay. So, so in the VS Code, we will work with the terminal. For opening your terminal, you can go in here and click on this part, and you will see the terminal in here. Or if you use the Mac, you can use the Control Dash, and in the Windows, you can use this shortcut. I'm not sure what was it. Yeah, you should be sure that you have the Git on your laptops. They already installed it on the university's laptop, but make sure you should have that. If you don't have it, we will have issue, and we will help you to install it from based on your PCs, Mac, or anything. So, we need to be in our terminal. We need to be in the folder of our repository. If you see in your terminal, these parts will be different in every PCs. But if you see the from prompts to the agents, you all will be fine. If you don't see that, just put and click CD, type CD space, and click and type from prompts to the agents, and be sure about the capital letters, and you will go to that folder. We all are in the same place, yeah? Okay. So we will start to run our first code, and we all need to be sure we have the connections with our local and also the Google Gemini's model. So I will give you a quick intro about the connections, about how we are talking with the LLMs and the models. We have one standard in the world which OpenAI make it, because they are leaders in this area and in these subjects. And this API called OpenAI compatible. All other models, even Google, are using this, and they are supporting this system. So if you want to change your model in your projects, you need to use this. All of them will support this. So in one side, we have our code, and in another side, in our local server, or in the clouds, which we already have it, like API, which we get it from the Google, we have the model. We have the trained model. Between that, we need API to send our process to the model's server, to the model, and get the output and show it how we want to show it to the users. It depends on you, or even you can use it in your codes. Okay? And this method and these APIs have some classes, have some methods, which, as I said, for all the models are same. You are seeing in your screen, in the right part, we have import request. This is the library which it's famous for using and sending the send and the get and the post method to the APIs and get the result from anywhere. Then we have the request post, we have the method of the post. After that, we have the link of our model, which what you see now, it's our local model's link. You don't need to change this, you don't need to modify this in our events until up to the challenge. You might need to change it, or you can do everything you want. You are free to use any model, and we will see what will be your results. The result will explain you about the challenge. Don't worry about it. Don't worry about it now. So after that, you will introduce and you will select your model, the model name, which in our server is the queen 2.534 billion. And then you will send a message. The message is a simple thing. The problem in here, you have the role. We have 3 roles, and it's standard in all the APIs. We have the role of the system, we have role of the user, and we have role of the assistants. These should be assistant. Please change it if you have access on the PowerPoint. We will change this. This is the assistant. If you send it as a role of the system, you will send the instruction, and you will send how the models need to be act for you. It will be like this in the content. You will say to the model, be as a software engineer, be as a civil engineer, or answer me in a really good literature as a, I don't know, pointer. Everything. This is the intro, and this is the way you want to model act for you to send the output. Are you fine with this? Okay. The user is the simple. This is the simple thing which in every request we will send. There is no any options in here. You will put a user and you will send your message. And it will be act based on the role you send it before. So if you send it in your system role, be as a software engineer, the message on the role of the user will be answered based on the software engineer's thoughts. Is it fine up to here? Okay. The next one will be assistant. I will update these parts. The assistant will be used for the chat's history. For example, we will have a code for that, and I will show it to you. If you, for example, ask from the model, what is the machine learning? And it will give you an update, the output, and it will answer you based the answers which they have. And in the second questions, you will ask what subject I asked about. You didn't mention the machine learning word. If you send it as a rule of the users, it will not know that. It will not have a history on the chat. But if you send it as an assistant user, the model will check the history, will save that history, and it will answer you based on that history. It's really important and tricky part for your challenge. Just make sure, just get these idea and get these hints. That's it. After that, you have the temperature. These are, as I said, you will have the temperature, and we will have 2 other ones. We will not move with those 2 because it's not related, and we will not use that. But temperature is really important for us. Temperature, yep. Temperature is the number between 0 to 1. If you put it as a 1, AI will be very creative, and it will give you a really creative answers. Imagine that. If you ask 1 question from the agent, from the AI, and if you put a temperature to the 1, if you ask it 10 times, it will give you 10 different answers. If you put it 0, it might give you the old answers might be the same. Did you get the concept of the temperature? All the models have this. And all of them is between 0 to 1. You need to use this in your challenge. Yeah?
So you've mentioned that temperature is something related to the responses. Like how
Yeah, it is the exact adjustment about the creativity of the answer.
So it will be like everybody uses one because it's more creative, or depending on the scenario.
Yeah, it depends on the scenario. Imagine that you have a code, you have a create an agent, and you have a model, and you are using the query. You have one answer, and you want to publish this, your codes to a company, and you don't know which temperature is good for them. You will put it as a 1, and you will see, no, these answers are not good for them. So what you will do, you will adjust this number to make sure your agents is best fitted on for them. This is one of the important part. And I can mention that you can code it this one based on the machine learnings, based on everything you know about the clustering of the data. You are not forced to put a number in here. You can adjust it even in any way you want. And you are free to do that today as well.
So add one tiny bit to the Daniel's. So what is the temperature, that the question you asked, yeah? So obviously, if we can select the temperature as 1, why not? The answer is more focused, more accurate, yeah? But it's a trade-off between because we make the system slow because it requires more processing cycle to do it, to get the answer, more computational power, yeah? Depending on the application that you need, yeah? You have to have an accurate result with a fast and responsive way, right? So you play with this number depending on the other modules that you implemented and what is the best fit for your application, yeah? So that's the temperature. So these are the features of the LLM. We normally, when we initialize the sample of the LLM, we assign the features right into it to say, okay, to suit more to this application.
Yeah, I updated this exact keyword of the assistant you might be used. You need to use, actually. So let's jump back to the VS Code and run our first model. Yeah. No, it's a flow. You can use any number between 0 to 1. You can adjust that. Yeah. Yeah. For the challenge, as I know, Reza will introduce everything and it will be explain everything about the challenge, what options you have and what options you don't have. Don't worry about the challenge, and you will see that. And even in our code, I will now show you which exact models we are using. Just, sorry. So, we need to jump to the session 1 and start our first code. We are all fine, and we are in the folder of this terminal. We are in the folder of the from prompts to the agents. I will go to the folder of the session 1. I will type CD. Just be sure you are coming with me. Session. If you put some letters, if you put a tab in your terminal, it will suggest you the folder which is available. If you go to the session 1, after that, sorry, just a quick.
So is everybody here in the same place? So you already clone your...
No, just wait about that, sorry about that. Just put CD 2 dot and you will come back to the folder. We need to set up our environment, and then after that we will go to the codes. For the setting up your environment, make sure you are opening the README MD in here, and you will see all the codes we needed. And be sure you are in here, in the line 38. In the line 38. We are in the folder, and now we need to implement and start in our own environment. Just copy paste this code and put it into. And after that, based on the systems you are using, just find your code and go start and activate your environment. If you are on the Mac, you need to use the first one. If you are on our university's computer, you need to use the PowerShell. if you are on your own laptop and the PowerShells didn't work for you, just use the bash. It depends on the scripts which your systems is using. It's not related to our codes. After you copy paste this code, make sure in your terminal, in the first part of your terminal, you will see the environment's name. Our environment name is .vmb. So, okay, we all fine up to here, yeah? Don't worry about the master. It's related to the branch of the GitHub. It's fine. I will just come. So I need to be a little bit faster. If you have any problem, I will come back to your PC or laptop and I will solve that. Don't worry about it. So we are in our environment. I will give a quick intro about the environment. In the environment, you can install every Python version you want, and it will not conflict with your own Python version or any dependency you will use it. If you want to be professional, you need to have the environment, because if you send your codes to anyone else, you need to send environment as well, because if they run that code, they will be in a big trouble, because they need to know your dependencies and the versions of them. So while we are in here, just copy paste the 54 and install the requirements. The requirements are the dependencies which we need to in this folder. It will start to install, as you see. And we will wait here until the next line of our terminal will come. Yeah, that's it. If you see this message, it's done, and you're ready to run our code. So,
if you switch to the university computer, it's possible, all the references are there, right? So maybe on your
just if you have any problem with your system, in the terminal, just type git. Type git and put enter. If you see this message, you have the git. You can use and you can move on with us. If you don't have it, you need to install that and just come back to our level. If you don't have it, please use the university system. Yeah.
So I have a question. How many of you already reached out to this page? How many of you already cloned the code? Please raise your hand. So half of the class. So it means how many of you couldn't clone the repository like this? So please raise the hand. We will come over and help you to clone the repository. Yeah.
So this part is a little bit tricky. It's about your implementing and adding the API to our system. I'm in this folder, and I need to go to the session 1 folder. What I will do, you can find it in here, in our README. Just be sure you are in here, line 96. And if you put the CD, session 1, the requirement file is in the line, for the first session, it's on the line 53. Yeah. You don't need to be in the folder of the session 1. You can install it with the previous folder, prompt to the engine. Yeah. So we will go inside of the session 1 folder. We will type CD session 1, or you can even copy paste it from line 96. After that, be sure you are in the session 1. This line means you are in the folder of the session 1, and everything you are putting there, it will show you what inside of that. So we will use this code, the cp.env.example.env. This is a regular and general command for copy and the paste in terminal. It will copy .env.example as a .env file. When you are doing that, make sure you are watching here, and when you click enter, this file will be .env, and you will copy and paste this. Token balas. If you need the token for the local, for our local model, it's on the line 72. So I now need to put our API to our environment. I'm in the session 1. I already copied the .env.example to the .env file. With only putting the CP and this line, you will copy and paste that easily. Click on the env, and you will see this env. We will see these files in every sessions, and you need to update this env in every sessions folder because the requirements are different. So if you see this env and you are setting the API and you don't see any result, make sure you are editing the correct env. So in the env file, as you see, we have 2 options. The first one is our, do you have any question? Is it fine? Okay, let me put the APIs, and after that, before running the codes, we will stop for that. Yeah. For in the env file, you have 2 options. One of them is our local server, and you will put the APIs in here. API is on the line 72 of README file, or if you don't access to the README file, if you don't open it, it's available on the GitHub website. We will copy and paste it from here, EY, after the equal, up to Y. And paste it here. Just make sure you will clear this sentence and copy and paste this in here. And then we need to implement our Gemini's API in here. We already put the model's name, and you don't need to change it. If you are interested in that, you can change it later. But for the event, we all use the flashlight model version. So you need to put your APIs in here, which we already keep it in the safe place. I will copy and paste this API key in here. And now, after all this done, you should save this file. If you see this dot in here in VS Code, means you didn't save this file. If you click on the Control C and push the Control C button, you will see this dot will disappear, and it means you saved the file. If you are not fine with the Control C, just save it from here.
Can you please repeat that API token from where you taken?
Our local one. You have a README file in here. Click on that. You will see the README file, and in the line 72, you will see our token. And now we need to be sure most of our friends will be in this step. If you have any questions, just ask. You are fine. Any questions? It's available on the Teams. Did you clone the repo? Okay. There's a README file in there. You mean for the controller? Yeah, it's for the local one, you can use it. But for the session file, we need to use the Google. Just make sure you have the Google API key as well. What? Yeah, the session. You can get it now because we are already done with the API. Just how many of you are in this step? You are not? Do you have any problem?
Having a hiccup to install the V in base, like it's all the grayed out. I did try that.
you a question. You can help each other as well, right? So that would be good. Anyone needs help? Okay. All good?
Some of you, when you creating virtual environments, the first step will be some of you Python, some other maybe code with Python 3. Okay, with Python is not very nice. Try Python 3.
Install the requirements. You just set the API key, the .env file. Go to the session. No, not yet. I'm just reading it. There is a .env file. You should rename it to remove .example.
Just the first line.
Guys, make sure you install the Python, please. If you didn't, then just let me know to help you guys install the Python.
So I think the best option is to use the PC university in the lab, right? So because on the laptop there are many missing components that you're.
Question?
آره میدم. Are we fine with the EMB? Did everybody set the EMB? Okay,
So
I will move
let's
on
take
with the
the-
codes. Yeah, because
yeah.
we need to be a little bit faster. We have lots of the codes to do. Okay, so after we set the EMB, I will just give this hint again. This EMB should be created on every sessions, on every folders. So you are not done with it. When we go to the sessions too, when we put the CD sessions too, we need to set up our environments and APIs as well again. So we are all now fine, and we are up to here. Just copy and paste these codes, and we are starting to run our first step, which it will give us our connections result. So I will copy this. Just make sure copy this part, not the common part. or if you do that as well, it will be no problem. But in some computers, there might be problem. Just be sure you copy this and enter. You will see this message in your terminal. You are using now, checking the LLM connection. I'm now using the local one. If you set both of them, the system will start to use the local one. If you didn't set the local, you will see the Gemini. Both are fine. Don't worry about it. You will see the name of the model, and we will just send the test input and output. Now we are going to the second code. We all fine with this. You see your connections, yeah? Could you please help? Because we have only problem here. So I will run the next code in here, the conversation. I copy this line, and I will come to the terminal and paste it in here. Now our system and our local will send us a result. If the university servers are fine, yeah, it's fine. I see my result. What these codes do, as you remember, I said the rule. I said to you, we have three kinds of the rule. If you want to use the history of the chat, you need to send the rule of the assistant. So if you are interested in, you can check these code, you can open this code, and you will see in here, we first send the system, as I said, we will say to the model, you will act like this. In here, it will be helpful assistant for university student. The user will send the content, the simple sentence. And if we use the assistants, we need to send our list of the chats. I will not go deep inside of this. Might not need this, but I need to mention that. So what we did in this code, when you run the step 2 conversation, as I said, you are asking the first questions which we put it in the Python code. What is the machine learning? But in the second question, it will answer you. The answer is not important for us now. And in the second question, you will see, this is the question. Give me one real-world example of it. If you don't use the rule of the assistant, it will not send you any output related to the machine learning. You need to use the assistant rule, so the systems will know it word will related to the machine learning. This is the purpose of this code, our second step. So we will jump back to the README file, and in the third code, we will see how the temperature will work. How, when we change the temperature, the answers will be changed. But how? This is the temperature. The first results is that with the temperature of the 0.2, and the next one is 1. You will see the focused version and the creative version. And in your code, if you put it 1, and if you send, 100 questions, you might see the 100 exact same answer. This is the purpose of these codes. So we will go back to our slides, and let's recap this slide. If you have any questions until here, I will be so happy to help. Yeah, that's it from me. Thank you.
Thank you. Yeah, thank you very much. So guys, I know that was the first try, but whatever we build now, we build on the things that we started, yeah? So if you're struggling with your own laptop, because the university piece is being sold all the required components there, right? So you might consider to switch to the university PC and catch up with the code. So we cloned the, just a recap, we cloned the repository from the GitHub, right? We developed the first command to interact with the single line, with the LLM, the local LLM. We learned, yeah.
Guys, when you change the file, please make sure we press the Control S,
Save.
all the keys, and then we try to run the command.
So if you, for example, add API, you need to save it in order to make it run, right? All right, guys, so we set up the first code, we interact with the LLM, and then we had a multi-interaction with the LLM, right? So now we are working in a terminal. Now the time is this time. You want to build a very basic chatbot using a Streamlit, right? So we can run a basic chatbot to interact with the LLM through the chatbot. Yeah, that's a bit nicer. Yeah. So I invite Ali to give us how to create a basic chatbot to connect with our LLM.
Okay. Yeah. Hello again. So.
Other guys are installing everything now.
Okay.
Yeah. Okay. So maybe.
If you can give us 5 minutes.
Yeah.
Yeah. No problem.
Okay. Let's start with in 5 minutes. Yeah.
So just.
How many of you installed and run the code? Raise your hand. How many of you installed everything and are ready? Okay. Okay. Just wait for the 5 minutes, and then we will jump to the next session to make sure all of you install everything and you're ready. Okay? Question?
چیزش کرده پنجره رو
ما چت رو میکنیم با استریملیت. حواسشون باشه که اینجا این بعضی‌ها که با لپتاپ خودشونن کامندش فرق میکنه. باید تو پایتون بعضی‌ها نه که ویندوزی
Guys, are you ready for the start of the next session? How many of you installed everything? Please raise your hand.
Are we good to go? Forward?
Yeah.
Yeah.
Please help your friends at the same time.
Okay.
Any problem? Or raise your hand, we can come over and help you.
So now we are going to know how to building a chatbot UI to have a more interactive environment. The solution in this workshop is Streamlit compared to some other options that you can have, for example, Django or Flask. It's much faster, much easier to implement. You can go to the website and see lots of things that you can do with this software. So the line that you need to run the Streamlit on your project is Streamlit run dash step 4. And now, if it asks for an email, just press enter. Now you have a live chatbot easily. Compare it to the time that you need to implement something similar with, for example, Django or Flask. It's much faster.
So guys, this is very simple, yeah? This is just proceed with the README file, yeah? And can you Ali show us the README file?
Yeah, the README file is there. I think one.
See, go to the README file and can you highlight the line that they need to copy and paste?
Yeah, just one second.
Excuse me, sir. So do I have to close the current terminal and open a new one and start?
No, you can continue with that. So it's 122.
Line 122, yeah?
So that's what I did. I just copy and paste the code and then press enter. So now you have the chatbot.
So guys, if you copy and paste this line in your terminal, 122, just keep it highlighted, please. Streamlit run step 4 chatbot, yeah? And Ali, can you run it? Line 122.
Yeah, I think currently we have that
Yeah.
here. Now it's the result of that
You
code.
will get this nice interface, yeah? This interface is connected to the LLM that you interacted previously through the terminal.
So is this interface designed by us or is it default, right?
Yes, there are some predefined design that you can use. The goal of using the Streamlit compared to Django and Flask is that you don't need to pay lots of time for using CSS, HTML, or something like that. So it helps you with front development a lot. Yep. So the command was this one. Also, if you go to the website, there are lots of samples that you can see. Imagine how difficult it can be if you want to use, for example, other solutions to implement these Python files.
Okay, so Thank you. So guys, I wait for you to try the first Streamlit link with the LLM, right? So when you run it, when you run your code, all right. Yeah.
The name of the institute that develops this AI is the Streamlit institution. So students workshop, what is language? Like generally? Yes, yes. It's a front end. I would like to use it. Maybe I'll show you. Just last question. What is this chatbot? This one is yes, it's integrated to the LLM model. You can ask it like ChatGPT.
So guys, I think I found the, so in the README file, in the very early part in the README file, you see, guys, this is very important part, right? So many of the error that you are getting now is because of this. So on the on the PC, we are using. You shouldn't go for the Windows one. Yeah, we should go for the Windows PowerShell. Yeah. So just paste that line to activate your environment. Yeah, and then try the rest. It will work. Yeah. So that was the issue that many of you get. Try this one, guys. Okay, shall we continue? I want everyone to see the Streamlit on the PC. Have you seen all of you? No? Yeah, and press enter. If you see welcome, just press enter. Is that you? Okay. Okay, I think we are now going to move forward. So what you learn in the Streamlit is very simple. The concept is very simple. You run a basic UI, you pass the message or prompt, yeah, the Streamlit convert it to the format and send it to the LLM, yeah, and the LLM will respond and the Streamlit will display the response to you. Very basic concept, yeah? And you already have the file, you can extend it or reuse it in other applications. Okay. So as mentioned before, about the system prompt that Hertfordshire is going to present for us, we are going to change the personality of the LLM, yeah, by the prompt that we send to the LLM, right? So Hertfordshire is going to give us a talk on it. Yeah, Here you go.
So, how many of you currently install everything and you're ready for the next session? Please raise your hand. So most of you are ready. Okay. So I know all of you get tired because installation part was so difficult and running everything. So how many of you, before they jump into the session, knows what's the meaning of the prompt? Raise your hand. What's the meaning of the prompt? What's the prompt? Only few of you? Did you use the GPT to help you to do your practice homework? I know all of you do that. Okay, please raise your hands. How many of you use that? Okay, this is illegal things. Please add this name. Okay, so most of you knows, in fact, how you can write a prompt and interact with the LLMs, right? Because we are using the LLM, we need to pass the data to the LLM, right? The LLM works with the prompt. That means prompt is everything for the LLMs. If you want to, for example, read the book and you don't have any time, you're lazy like me, and you want to use the GPT to summarize it for you, you will upload the PDF and then ask some question. In fact, the LLM will embed the PDF, read the PDF, attach the PDF files, attach the contents in the PDF to your prompt, and will send it to the LLM, because LLM will work with the prompt. So prompt is everything for the LLM. If you want to use the database, for example, to integrate the data in the database with your prompt or the query, you should update your prompt, because the LLM input is the prompt. So as I said, prompt is everything for us. If you want to use any different agent, you build your agent. For example, suppose you want to have an agent to manage a smart home, to collect the data from the sensors, temperature sensors, I don't know, something like that. And you want to use the LLM in this case for the managing the temperature of your house, you should append the temperature and data to the prompt. Why? Because the prompt is the input of the LLM. So, in the Pythonic language, if you want to use the prompt or any other LLM language SDKs, Anthropic, GPT, or other LLM models, you should follow this template, this syntax. You should create a message list. At the first one, you should choose the LLM's role. Daniel talked about this one to you. LLM should know that, who's talking to that, and in which area it needs to generate a response. So, say for example, your role is the system. You want to help. You are a helpful assistant. If you are, for example, AI engineer, and then you want to build a system for civil engineers, you should say that you are a civil engineer, because based on the civil engineer's materials and the knowledge, the LLM in this case will generate a response. Okay? And the second one is the user. At the first line, we initialize the LLM. That means its role is the assistant. And in the second line, we should say that, okay, what's the role of the user? The user or the client that want to use this LLM. Say, how can I build a bridge? In this case, the LLM, first of all, will read the first line. It says, okay, I should be an assistant. And the second of all, it says, okay, the users ask me, how can I build a bridge? That means a civil engineer is asking me about building the bridge, and as an assistant, I should produce the results. But it's not all the things, because first of all, tone and the expertise is so important. For example, if in the first line we says, you are a robotic engineer as an assistant, help me to answer the following prompts, the LLM, based on the robotics engineer's materials, will produce the result. If you use the civil engineer instead of the robotic engineer, it will produce the material for the robotic engineer. That means the tone and the expertise will change. So let's have an example together. In the steps folder, the steps 5, if you open the code, yep.
Say, as a robotics engineer, help me cook rice.
Yep. It will, let me come here because of the speaker. It will consider that this point that you are a robotic engineer and you ask it to generate a response. In this case, the response will be personalized to robotic engineers. It will use the keyword that is familiar with the robotic engineers, right? Do you understand that? Is it clear?
Yeah, but as a robotics engineer, it doesn't make sense to help someone to cook rice. So what does it do in that case?
It doesn't matter what's the rise or the different things. It tries to generate a response using the robotic engineer's keyword. For example, for me, if I said I'm a robotic engineer, help me to develop to build an application, the reminder application in Android, it will use the keyword that the robotic engineers are familiar with that to convey his thoughts to me. For me, that's because I'm not a robotic engineer, I couldn't understand that. But if I change its role to say that you're a software engineer and then help me to build an Android application, it will use the keywords and the sentences that I'm familiar with that. I want to say that the role is so important. If you want to build the agent for civil engineers, you should introduce the agent, introduce the LLM that is your assistant to build the model for the civil engineers. It's really important, okay? We personalize the response. I just want to talk about that. The personalization, the response is really important. Okay. So let's go to the step 5 of the Python. Here, we designed 3 different prompts. At the first one, we says your role is civil engineer. Second one, robotic engineer, and the third one, creative the writer. And then we will pass the same prompt to all of them. Please run that and compare the results. The results should be very interesting. Let me run it here. Yep. Question? Okay. one.
You have used the Streamlit command. No. Yeah. Streamlit runs that.
So if you want to run this, you have to stop the Streamlit. Yes, you just break it, Control C a few times, and the Streamlit will stop, so you can run the next piece of code. Yeah? Press Control C a few times.
اون گی کردم اینجا من نمیفهمم چی انجام دوستشون دارم اینو با استریملیت برام بشه
Streamlit run this one.
اینجا yep. Okay guys, using the Streamlit you should run the step 5. Let me show you again here. Goes to the session 1 folder, please, here, and run at the type Streamlit, run step session 5. It will open the session for you. Now let's test it together. Yep. Here. This one. Yep. Press the red button. چهار تا عکس از عکس از من عکس ریزی So, how many of you run the Streamlit and have access to this file? Raise your hand. Okay, most of you. Okay, so press on the compare button, compare response button, and you can see the response. As a civil engineer, the agent produces this response. But as a robotic engineer, if you scroll down, you can see that it's used, for example, LiDAR, use CAD, because it's a robotic engineer. It tries to generate a response based on the LLM role. That's all the thing that I want to talk to you. Is it clear, guys? Yep, question? No? Okay, it's really important. Just learn that system prompt is everything in LLM. If you can design your system prompt, you can adopt the LLM for your agent, right? Yep.
How sending the prompt in a YML format differs for LLMs in terms of token consumption or the reason?
You should design your system prompt. For example, let me show you. I think I have something here. Oh my God. Okay. For example, suppose this is my system prompt, and I want to attach a YAML file or MD file. Okay. You can say that.
No, I mean, if you're giving a prompt in a YML format.
You should, I want to say that you should submit this prompt to the LLM. Is it right? If you want to have a YAML file, first of all, you should open the YAML file in the Python, extract the information. When you pull out all of the line, append that to the system prompt, because the LLM will accept the text. Okay? This is the flow that the GPT, Killer, or everything will do that. When you upload the PDF, they never pass the PDF directly to the LLM. They have different tools. They will read the PDF, pull out all of the text, and then append it to your main prompt and pass it to the LLM.
So if you're giving the prompt in a YML format, does it uses less token or is it more efficient for the LLM to understand, or is it the
This is the different things, to be honest. The token is really important. OpenAI guys introduce themselves as a token billionaire because they don't have any limited token, okay? So, but for us, because we should pay for that, it's really important. In this case, there's one of the topics named context engineering. You should, before they send the prompt, the long prompt to the LLM, because it will charge you, you should summarize the prompt. You should find the main concept of the prompt and have those useful material and removed unusefulness. For example, spaces, or I don't know, different things. This is the context engineering. It can help you to have a shorter prompt. It definitely better for you. Yep. Okay. Question?
I have a
Technical question?
So, the
Yep.
question is, now we see ChatGPT, Gemini, all this. So, are those somewhat similar to this, but they are just a bit advanced and this needs a lot of more working to be of that?
In terms of the prompt, system prompt, or the accuracy?
The accuracy.
The accuracy is different, to be honest. The number of the billion parameter that they have and the reasoning part should help us to compare the models together, okay? For example, in the university, I deployed Qwen with 34 billion parameters. So definitely, compared to the Anthropic model or the GPT model, that are the larger models, so the reasoning will be different, okay? So the number of the billion parameter is so important. Guys, was a really good question. If, as an AI engineer, if you want to build your agent, you should find the suitable model for yourself. It depends on the specs and the hardware that you want to use. For example, if you have the embedded system look like a Raspberry Pi, so definitely you cannot deploy the model more than the 7 billion parameters. So in this case, the reasoning part is not look like the GPT because you are using the smaller model, okay? But you can run that. So based on the purpose of your project, purpose of your agent, and all of the requirement, you should have a trade-off between the model reasoning accuracy and also the size of the model, right? Did you get your answer? Clear? Cool.
Okay, so guys, we have more or less half an hour for the lunch, yeah? So we're trying to wrap up the first part of the workshop, right? And we come back after lunch to continue, yeah? So can you proceed?
Yeah, so up to now, you learn how you can use the Python to interact with the LLM, Gemini as a cloud solution, and our local model as a local systems. And then we show you how you can use and adapt the Streamlit to create a UI for your AI agents. And you use what's the meaning of the system prompt. And please keep in your mind, system prompt is everything for you if you want to use the LLM, to be honest. And in the next session, after the launch, I will talk to you about the MCP, and we will start to build our first agents together. Right? Question? Okay. Done? Question? Reza, can you help?
Start at 1. Yeah, you just said a mistake. We will start our launch. We'll serve at 1. You can continue.
Okay. So guys, how many of you run the Streamlit and produce the result? Okay, so do you have any problem? What are the rest of you? Problem? No?
اسلاید بزنید من یه توضیح مختصری بدم توجهشون جلب نه آخه شما باید
نه بگو.
Okay. Okay, guys. So as I said, lunch is in half an hour. Yeah. So since more than half of you attended, so be prepared to get two portions. Yeah, of lunch. Yeah. Otherwise, I have to eat everything. Yeah. Okay, but in half an hour, not now. Yeah, hold on. So, but in 30 minutes now, we are going to make the most efficient 30 minutes of the workshop, no? Because we are going to touch a most important topic in the AI engineering, right? MCP, right? So, Kashar will continue with the MCP. So, and then after lunch, we come back, we see some implementation on Python. Yeah, over to you.
Okay. So, before continue, let's review the system prompt again. Did you read the prompt responses that we generated here? Did you find the differences between them? Yep. So currently you know what's the meaning of the system prompt. Now, the next step is the MCP. Suppose we have a smart home. It includes various type of the sensors. You want to collect the sensors data, and then using the system prompt,
AI actually, like Python code is pushing the API in order to get these responses. Is it pushing something as in terms of prompt or?
yes, everything is the prompt. Let me show you the source code. Just bear with me, please. Thank you. Here, I have three different prompts, right? It's a Python dictionary. First of all, I will use this key as the role of the agent. I want to say that you're a civil engineer. Okay? Okay. It's really important, to be honest. It's good to take the time for this one. Yep.
For example, if I search the same thing on Google, like just the normal browser, there are high chances we might get almost same type kind of answer. So how is it really different from that or this?
First of all, the Google search engine is not an LLM model, okay? This system prompt is the LLM input, okay? When you ask something from the Google, not the Gemini, Google search engine, it will try to find similar pages or the result based on your keyword that you search. But for the LLM, first of all, the user cannot see that, to be honest. As an AI engineer, you should know that, okay? So for the LLM, first of all, if you want to have an agent for civil engineer, for example, you should let the LLM knows which users, which type of the user, what type of user will interact with the LLMs. If you use, say that, for example, you are a robotic engineer, and the civil engineer wants to interact with this model, let me show you, according to this example, as a robotic engineer, in its response, it used the CAD, I don't know, the LiDAR, I see that it was here. It used the keyword that is familiar with the robotic engineer, but for civil engineers, it's out of the topic. Okay, I want talking about this. Okay, so question? No? So we learn. Yep.
So use different like Gemini models to respond in a different way. For instance, I use Flashlight. It responded me with paras.
It not depends on the Gemini or the Anthropy. I'm not talking about the LLM models. I'm talking about the rules. You know, the system prompt, by system prompt, you will control the LLM. Okay. If you says as an assistant, you are my civil engineer, and then ask something from that, it will produce the result that is familiar for the civil engineer. That means it will use the advanced keywords that the civil engineer can understand that. For example, if you said me, what's the CAD file? I don't know. But for civil engineer, CAD file is totally understandable, okay? I'm talking about these things, not about the LLM models. If you're talking about the comparing the reasoning part or the producing the result, it's a different area. To be honest, this is a difficulty that we will have the Anthropic, Gemini, and the ChatGPT. Each of them has their LLM models, okay? But their accuracy is different. System prompts cannot enhance their accuracy to have the same model with the same response, okay? But the type of the generation, the response is totally different. This system prompt will push the LLM to find that who is interacting with that and what type of response it needs to generate, right?
So guys, sorry, could you please continue? And if you have any question, we are happy to answer during the over the lunch break, right?
Okay, because we are in the time. Okay, so back to my example. We are a smart home. It includes the different sensors. We collect the sensors, and then we want to use the LLM as a decision maker to help us to control the house. How we can do that? First of all, we know that we should append the sensor data to the system prompts. Okay, that's clear for us. And the question is how we can connect the sensor directly to the LLM. This is the question. MCP, in this case, comes to help us, guys. For example, all of you, I know that, upload the PDF to the GPT and ask the question about the PDF. In fact, GPT has an MCP server, pass the PDF to the MCP as a tool. MCP will read the PDF, pull out the information, return that to the GPT. And the GPT will append that to your prompt and then will pass it to the LLM. The MCP role is to find that which information do you want to get and try to collect that. It can be, for example, a scrubber. You can use it to open the website, collect the information, and then pass it to the model, right? Question? Did you understand what's the MCP, guys? Is it clear? It's a tool, it's the gateway. So, for more clarification, as you can see in this diagram, when you send a prompt, the LLM will understand which MCP you need to use. Because when you design and deploy your MCP servers, for each of them, you create a description. For example, it says, hey GPT, if you need to read the PDF, run this, use this MCP file. So based on the prompt, the LLM will understand which MCP needs to run or to trigger. And LLM will get the prompt, find which MCP client needs, and will trigger the MCP client, and MCP client will start its task to produce or to analyze the data. For example, if it's a PDF, it will load the PDF, read the PDF as an OCR module, pull out all the information, and return it to the LLM, and LLM will update the system prompt and will use that one. So, if you want to review all the steps, first of all, you need to send a prompt to the LLM. The LLM will receive your prompt, and based on the MCP servers that you register for the LLM with the description, for example, is for the reading the PDF, it will trigger the tools or the MCP and pass your data to that MCP and wait for the MCP to analyze that, pull out the information, and then when it's received the information, it will update the system prompt to append those information and then pass all of the things to the LLM for the producing the result. These 5 steps will happen as an agent. Agent needs to pass these 5 steps again and again when it's received the information. Yep. This side. Question? No? Is it clear, guys?
I'm struggling to understand the MCP servers.
So, suppose you want to get the everyday weather, for example, of the Hatfield, and pass it to your LLM, to the agent, to based on that make a decision, right? How do you want to do that? What's your idea about that?
We have like a function that returns something and now we're going to put there.
That function is an MCP.
Is it a server?
You can have a server, but also you can deploy it on your local machine.
What's the difference between the MCP and just a function call?
To be honest, the MCP, they are the same things. Anthropic introduced it as an MCP, Model Context Protocol. OpenAI used it as a function calling. Okay, but because the Anthropic is a state of the art and they focus on the MCP, in the community of the AI engineers, they name it MCP. And also, there are various websites. What's that? Yeah, for example, this website, you can find the various type of MCP as a free, or you can pay for one of them. For example, you can find some MCPs that can go through the social medias to read the post and then inject the information in your system prompt and use them. You know, the MCP is a standard protocol for gathering the information for your LLM and append it to your system prompt.
So, can you please introduce this website and go through this?
Yeah, because the MCP is really important for you, for your agent, to gather more information about the situation or about the purpose of your agent. So there are various type of the website that they deployed and they build MCP servers. You can use them. Some of them is free, and for a lot of them you should pay. But mcpservers.org is one of the famous one. And if you have an agent, for example, to get, let me check something. I don't know, for example, for the, what should I say? The PDF, yeah, the PDF is a good one. Yeah, for example, for the PDF, for example, Agent Reader is one of them. You can find some information about the MCP. You can integrate it with your agent when the user upload the PDF. So you cannot, as I said, in the system param, you cannot send the PDF file to the LLM. You should read the PDF, extract the text or all the information, and then append it to the system prompt. This MCP can help you. You will send the PDF file to this MCP, it will read that, pull out the information, return the information, you will receive the text inside of the file, and then you can append or update your system prompt and pass it to the LLM.
Is it like a library but for agents?
Yes, it looks like the library, but think beyond the library. Your agents will interact with most of the different gateways. For example, you want to get the information from the Amazon about the orders, for example. It looks like the API calling, but if you want to integrate it with the LLM, you should pass some protocols. What protocols? All the information should have the same template, not the JSON, for example, text, because you want to append it to your system prompt. MCP comes here to say that I will apply same protocol that is suitable for the LLMs, and I can ensure that when you receive the information from the providers, all of them is readable for the LLM, and you can append it to the system prompt, right? Cheers. Question, guys? Just take the time and think about the system prompt MCP, because to be honest, it's really important. If you want to design the agent, you should design your MCP servers, you should design your system prompts, because the LLM will receive the text, and the text is system prompt. Okay? So let's back to the slide.
There are a few more slides until the practice building the first agent. Yeah, I think is it. So that's the robotics agent. So we already covered. So guys, as you see here, so when we're talking about the agent, yeah, agent is already connected with the concept of the MCP. So whatever you want to do, right, beyond the text communication, we already know how to communicate text with the LLM, right? Send a question and LLM look at the database and then answer it, yeah? But when we want to do action, for example, as Kasher said, we want to ask input as user to upload the PDF and do some action. What is action? Read the PDF, understand it, extract the keywords, and so on. LLM itself is unable to do this, yeah? So we have to look at the proper, a good implementation of an MCP server. We have to find a good one or implement our own, yeah? To attach it to the LLM, yeah, to do the job, yeah? So there was, for example, a website that you see in which there are many MCP servers for free. You can download them and try. Have a go with these, yeah?
So I have a question. In the example,
Yeah. PDF.
right? That's like a two-way service, correct?
It's like, yeah.
So I was thinking that, say I'm building, I'm just building a piece of software. Why do I need an MCP server? Why not just build that service within the software and maybe just make references or make.
I mean, yeah, okay. So you're talking about the agent or regular software?
In our example, the PDF reader.
The PDF. Do you want to answer?
Yeah, sure. I mean, that's a very good question, actually. So let's think broader. Like you're going to for example, you're going to create one agent. You're going to create, you won't end up to one agent. You will maybe end up to 3, 4, 5 different agents, right? You're going to create, or you're going to replicate, or you're going to embed the same code in every agent, or you're going to have pre-built tools and use it for different agents. Which one is more efficient? Having a tool, okay, which you can attach to different agents, right? So that's why we're using MCP. MCP is a standard protocol, and all agents can communicate, can use different tools through the MCP. So that's why we're going to use MCP. Okay, clear? So you'll see in the next, you done, Ulfas?
Yeah, please go on.
Okay. So we're going to see in practice now how we can use MCP and how we can create tools and use to attach an agent to it in MCP protocol. So the project we're going to explain is a robotic agent. So what this robot agent's supposed to do is you're going to specify a task. For example, can you explain to me, can you ask me, give me a prompt, a task, a robot supposed to do something in your mind, a robotic task. Ask to choose an actuator for a specific task. So can you explain more what is the project, what is the task? For example, yeah? Yeah. A robotic arm for pick and place task. So it's very generic for pick and place. You can say, for example, pick and place from a conveyor. We can mention the speed of the robotic arm because different robotic arm may have different working performance, the speed time. So yes, so this robot, what we're going to do, we're going to give some information to the LLM model. An LLM model based on the request will design a robotic agent for you. I mean, practical robot for you. For example, you're going to ask, I need a pick and place robot to pick object from the conveyor and then, or belt, place it somewhere else. So the output will be, the agent will tell you, okay, you need, for example, a Delta robot with a specific, for example, model is able to perform this task. It's kind of suggesting, kind of assistant, right? So let's see how these things will work. Yes, is it clear the task this robot's supposed to do? Okay. Yes, this robot's supposed to perform, this agent's supposed to help you to design a robot, I will show you in the code how these things working. But to run the code, we have 3 steps in your repository. You can check them all. And let me jump to the VS Code and show you how it is arranged. So session 2, if you go to session 2, there is robotic data. What we have in robotic data, we have information about components, about actuators, and about sensors. Okay, these are kind of like, for example, you're working in a company, you have some catalogs. Based on this catalog, based on this information, you have to design. These are your vendors, for example, right? So based on this, you need to design a solution for someone, okay? Because you're only limited to these providers, for example. What we have inside, the actuators. The actuators, for example, we have different sort of actuators. I mean, these are practical actuators. If you search, if you Google it, for example, here, if I go to the Google and search for it. So this is, for example, this model of actuator is being listed here. Or as an example, I'm going to pick another one, another gripper. So this is another one. This one, the soft one, the soft robotic. Or for the components, we have different components available which we can use from the list being listed in our design. So yeah, that's a robotic arm, one of them, and we have many of them. So what would happen if I mean, let me ask you a question. How we can design this agent? How this agent can read these JSON files and design, come up with a good suggestion for us. How it can perform these things. How we can read this JSON file in MCP, and we need to design a tool to read a JSON file, extract the information, and feed the LLM model, right?
Extract the information as a text, right?
Extract the information as a text. Yeah. Look, step 1, it shows you, for example, is the data exploration. If you run this step, let me do it. You can do it same time running it. So what you need to do, remember, for every session, in session 1, what you did, you create .env file, copy your tokens, and install your requirement. You need to do the same step for session 2. The first step in session 2 is installing the requirement in your session 2. For example, I move on to CD session 2. I hate Windows. Okay, so pip install dash or requirements. Hopefully it will work. Okay. So yeah, you can see the same step in your README. If I go to the README here, session 2. Yeah, just raise your hand if you need help. Yeah. In session 2, first step is CD session 2, go to the session 2 directory, install the requirement, and you need to set up your .env file, which is about setting up your tokens, right?
We did that in the session 1.
Yes.
Below that, we can rename the .env example. If you have any
the reason we are repeating these things, because it's very important to you remember the steps. Setting up the environment means setting up your token. I mean, we're repeating these things for every session and setting up the requirement. These are very important deployment level setup, which you need to learn. We could do it once, but we're just trying to repeat it to make it, I mean, normal. Oh my. So look, so the next step is, if you check, initially, there is no .env. I only have .env.example. What I need to do, I need to make a copy of it. Right? This is the raw .env file. I need to make a copy and then paste my token here again. I mean, the same step we did for the first session. So how does it work? I mean, let me just press enter here. So Control V, yes. So simply you can perform this by cp.em.example. So it's this command make a replica of the existing template to the new file, which is .env file. So if I press enter, it makes a new .env file, which I need to now copy the tokens here. I need to close this. Right. So if you see, so there is no token available here, right? So easily I can copy from the previous session. Yeah. So copy them all. Go back to the here. Just paste it. For the Gemini as well, I'm going to copy the token and then paste it here. Easy and sweet. Okay. Control S, don't forget to save your file, and then you can now run the steps. So Python steps and step 1. Face error. Let me check my okay, we have some المشكلة چیه؟ پایتون باید باشه.
نه این ریتمی اونجا باز بذارید، از روی همین خطش بگید بهشون. اینو کپی پیست کنید.
آخه این okay. I mean, I try to use the autocomplete version, but so we can easily follow the steps. So we already copied the .env. The next step is running the step 1 by copying paste. Okay, it's working. So the first step is data exploring, which means exploration, which means we just simply, if you go to the source file after step 1, we just simply read the files and extract the information and print it here. But it's not MCP. It's just a function reading file. We want to make it as an MCP, right? So that was the simplest step. So the next step is, I mean, you can copy the step 2 and paste it here from the README file, or you can just simply edit the file. Look, you can go here for session 2 and copy this line and paste it here. So this one tests the MCP tools directly. So what is MCP file? The source file of MCP is available here. Here we wrote down the MCP related codes, which we create different tools. For example, one tools we created is search component. I mean, tools in this case is nothing, just a simple Python function, okay, for now. But the way we're connecting and using and reusing them is, but you're repeating saying tools. Tools is here just a simple function, right? So this is a function, search for component. It's just reading the JSON file and search for the specific component. The other tool is searching for sensor. The other one is searching for actuator. And the other one is getting the component detail. I think we had 5, yeah. And the other one is recommend a platform, which is a robotic platform. And that's all about the tools we have. So you can find the MCP tools in Robotic MCP Tools server. So if you want to add new tools, you should add it here. So this is part of your final challenge today. Create some tools in your MCP server. Where? Here. Okay. So yeah, that's the source code of the MCP, and that's the last agent we need to run. So I think here, if I run the second part, which is your README here. Any questions so far? All good?
Yes.
Good. So MCP tools directly, and this is a full agent we're going to run. So the full agents, what suppose a full agent do? Propose us a solution for a specific robotic task. Okay? If I run this here, oops. Trying to make it more readable. Yeah. So it will ask me about the prompt, the input. Okay. So one of you, please ask for a problem in robotic. Do you have any idea? Perception?
Build a robot for conveyor belt.
Say again?
Build a robot for conveyor belt.
For conveyor belt? Let's see. So, need a robot to just only conveyor belt to pick up an object from belt and place on another. So let's see. Agent is thinking to find a solution for us. So let's see what is the solution. So from top, if you track the information, so the output saying that based on the given information, the given task from a conveyor belt and placing on another belt, we have some recommendation like, so the robot type we can use for this task can be a manipulator arm, and the manipulator arm can be RA60 based on the, RA60, I can search for it, so which is I'm going to, just wanted to search in Google and show the picture, which is suitable due to the versatility and ability to perform a robotic task. So let me just search for it. I think it's the same. It's the same, yeah. So they suggest us to use, for example, this manipulator and what sensor? The components in a robotic arm, the required components 6W of arm. Again, repeat the same things. And so again, a manipulator with a wheel base, a mobile base attached to it. So it understands we need to pick something from the one conveyor and place it somewhere else, right? So it can be a mechanon base, mechanon wheel base, like which is an omnidirectional robot. And like this, it says you can attach the manipulator on top of this wheelbase mobile platform to perform your task. So the sensors, it says you can use a real sense sensor, which is an RGBD camera. If you check it out here, so it's an RGB. It comes with a depth camera and RGB sensors. So it's the perception part of the robot, and the next part is the infrared. I mean that also can perform for navigation tasks as well, or this one. So I mean you can search for all the results. I don't want to take much time. So and then see what is the suggestion.
They're gonna hate us if we delay the lunch, yeah?
Don't worry. I mean, I almost finished.
We
Yes.
have 45 pizzas, so almost one for each of you. Yeah. Don't worry, a lot of food there, right?
I think they like more knowledge to compared to food. Which one do you like more, food or knowledge? See. Look. So as the last part here, so I mean, it's just repeat what we already did. We had some MCP tools we provide for this agent, and create an agent easily to connect the MCP server to use these tools. So yeah, these are the diagrams. Again, repeating whatever I already told you, and that's all about first agent. You're gonna use this agent in the next step in the challenge, A to A. Yeah,
go on.
error.
Yeah, you have to wait after lunch, yeah? All right, thank you very much, Reza, for your presentation.
Thank you so much.
So guys, the lunch is arrived. Now, yeah, we are having lunch, and then we come back in 45 minutes to 1 hour. So it's getting more interesting. So we are moving towards multi-agent integration with LLM, right? Okay, thank you very much for your attention. Yeah, let's see if they have already arranged for lunch. Yes, come on. Thank you.
It's something about the MCP of the Let's try. Let's see if that works. It's still the same thing.
این رو بذاریم به لانچ.
No match.
ولی منتی رو باید میرفتیم.
صدا رو باز کردم. فقط شما نیستید، منتیه. منتی عوض کردی جاشو. اینو رفتیم دیگه.
اینو رفتیم ولی من وقت نکردم توضیح بدم.
الان شما میگید.
نه اما منتی بگی اون دیگه کامل گفتم، این کد توضیح
باش.
لازم نیست.
یه دونه منتی داریم. آره.
بعد منتیه، بعد من میام اوورویو میدم.
این نمیدونم چیه.
این من اوورویو میدم.
باش. بعدش خشایار رو باز. پس میریم روی منتی. Let's go.
On microphone. Is it connected the microphone and everything? Where are you? Ali? Menti. All right, so we can start shortly, but let's wait. Yeah, come in. All right, so okay, I think most of you are here, so I think we can start. So I give you a recap. First of all, I really hope that you enjoyed the session in the morning. We did our best to teach you something meaningful. So this is a big topic, yeah, AI engineering and agentic AI. There are many books on this, yeah. The aim of the organization team was just to touch and introduce this concept to you. And as a researcher or as a master student, now you are able to explore more, right? We don't have time to dive deep into each topic, but now you are at this stage that you can explore it by yourself. When you hear about the terms that you learn, when you hear about the MCP, LLM integration, architecture, system engineering, no, thank you. You can catch up by yourself. All right, so this morning we started from scratch, right? And then we introduced the theoretical aspect of the agentic AI. What does it mean when we say the agent or large language model? What are the differences and how they can complete each other? And what is the main role of the LLM in the agent architecture, right? So that's the heart of the agent, LLM, right? So we implemented some text communication internal with LLM, right? And then built on that, we developed the first UI using a Streamlit. So we learned about the Streamlit a little bit and how to integrate it into the LLM. So that's slightly easier to have a chat with the LLM in the proper user interface, right? So depending on the application that we are developing, we might personalize the LLM, right? Sometimes we want to LLM to be a doctor, a teacher, a nurse, or a civil engineer, or robotic researcher. So we learn about the system engineer, how to change the personality and the functions of the LLM. Okay, this topic called system prompt, and we implemented something. You see the differences, and we could compare the output, right? So we talk about the MCP. MCP is a middleware between the user prompt and the tools, yeah? Whatever you ask the LLM to do, LLM is translating it and deciding which tool is required to do this prompt. For example, we mentioned the PDF reading, yeah? When you ask the LLM to read this PDF, LLM itself is not able to do this, yeah? But can trigger the proper tool to do that, right? So for this reason, you need to link the MCP server into your architecture to translate the input and pick the proper tools to do that and return the values, yeah? So that's MCP. So we see a website. There are many MCP products are for free. The main website, Hashara reviewed the main website for you. So you can also explore to get more, right? So that was more or less what we learned this morning. This, from now on, is getting even more advanced, yeah? We are touching the RAG topic in the agent development. But before that, Ali is going to ask you a few simple questions to track, so we are tracking your progress, yeah? In order to see how we present the RAG and the rest of the workshop, yeah? Ali, could you please show us the questions?
Okay, so if everybody joined the Menti, now we can go for the questions.
So just scan it or go to the menti.com and enter that code.
Yeah. So particular thing. Just okay. So now we want to analyze what's the level of you based on the concepts that my colleagues taught. Now we can go to the next slide. I think most of you answered. Yeah, the next one. So, based on the last presentation, the level of the MCP activity was too difficult, slightly difficult, about right, or too easy? Okay. let's go to the next slide. What would help most in the next session? To have more examples, more coding support, more theory, have more time, or maybe more troubleshooting.
This is the last question. Yeah. Okay, so what would help most in the next session? So what would you like to receive in the next session? More coding support, yeah. Imagine. So guys, please make sure to subscribe our channel, yeah, to support us, to be seen, yeah. We are uploading all this material. We divided it into different sections because currently it's like a 5 to 6 hours video, right? It's difficult to explore, right? So we split it and then we re-upload this material into the channel so you can access later. And also we will post the link of the GitHub repository. You already have the copy of it, yeah? You can upload on your OneDrive right away, so you don't need it. You can reuse it later, yeah?
Finish?
Yeah.
Maybe we can finish.
How many?
37 from 40.
That's very good. The feedback is completely aligned with the rest of the presentation. We're going to present more examples.
That's perfect, yeah. Thank you very much, Ali.
No worries, just 1 second.
So let me see the next topic that we are covering here. All right, so we see this. So whenever you search about the MCP, Agentic AI courses, yeah, this kind of course, of course, I mean, in a more controlled environment, they are covering more or less the same topics that we covered today, right? So, but the most important ones that they aim to cover are MCPs and RAG. So RAG is something important like MCP, right? But it's a bit more advanced, yeah? So we are trying to do something with RAG now, and we will see a Python implementation with a Streamlit. And starting from that, we will build another agent. So we built already robot agent, right? We will build another one, right? And then once you are confident with the agent implementation, we will introduce the challenge, yeah? It's a new problem that you have to think, explore internet, have a chat with LLM or whatever, yeah? To implement it, and there is a price for it, yeah? Okay. Yeah, I invite Hertfordshire, please come. Yeah, thank you, it's over to you.
So, okay guys, how was the pizza? Did you like that? I remember that you said that the knowledge is more than the pizza. What's the nonsense? Okay, so let's continue. And yeah, how many of you knows what's the RAG? Do you know what's the purpose of the RAG?
Yes.
No? Yeah, what's that?
So it's basically to retrieve
Uh-huh.
the data from the source,
Yep.
like a website, to verify.
Yep. Sort of, okay. So one of the problem that LLMs has is hallucination. That means most of the time when you discuss with the LLM, you can understand that it will generate the totally bullshit things because it will have a hallucination. So in this case, we need to help it to understand what's the main concept, what's the fact, to prevent of the hallucination. RAG is one of the methods, that's the useful methods that we will use that. But it's not only the purpose of the using the RAG. Suppose, do you know what's a train line application? Yeah, did you use the train line application? Yep. Train line application is an application for buying the train ticket. It has an AI chatbot. You can chat with that about the destination or the origin. But you cannot ask it about the mathematics or the robotic, because it's biased only on the destination and the trips. That was the RAG. In fact, using the RAG, you can bias the model or the agent to respond about a specific topic, not about all the thing. For example, suppose you want to build an AI agent, I don't know, for the student in the university to answer the question about the campus, lecturers, courses. But because you want to use the, for example, GPT token, GPT API, definitely you don't want to enable the student to use your agent instead of the GPT, because the GPT will charge you. So in this case, you should limit the chatbot to a specific topic, that is about the campus and the question regarding that. In this case, you should use the RAG. RAG come to help you. So how it works, it looks like the MCP, to be honest, and it will update the system prompt, because the prompt is everything. When the user sends a query, you have a database of the validated data that you provided that. For example, about my question, you have a database, the graph database, include all of the information about the, for example, University of Hertfordshire. When the user sends a query about the courses, lecturers, and different things, the LLM, first of all, should find those parts of the information that is related to the user query in the database, restore them, and then append them to the system prompt and pass it to the LLM. By doing that, the LLM can understand it should only use this type of the information, not its own knowledge. Because the LLM has a different knowledge about the mathematics, about the different campuses, different university, but RAG can force it to only consider University of Hertfordshire information, not the other university. So user send the query, then based on the query, we will embed the query, or in other words, we will try to find the similarity between the query and our knowledge that we have, and then we will retrieve that part of the knowledge that is related to the user query as a metadata, and then we'll pass it to the LLM. So let's have an example together. Please go to the session 3. Look like the first and the second session. First of all, you need to install the requirements. Please do that and create your .env file, and finally run the RAG demo. The RAG demo file will provide the more information. In my example, for example, the information about the University of Hertfordshire. And finally run the Streamlit to interact with the agent to understand the difference. If you have any question about the RAG concept of the RAG and other things, please let me know. Yep. Any question? Question?
So yeah, what you need to do in the demo presentation, you just need to go to the session.
Session 3, right?
Yes, session 3, and run. Yeah, we'll do. Sorry. So the same things. You remember in session 2 we create the environment. So you should do it again in session 3. Copy your token and create your, install your requirement, copy the token to get access to your LLM models, and at the end, run the demo, I mean, these two running the same. This is the Streamlit version of this. So if you run the first one, it's run in the terminal, and you will get the result in terminal. And if you run it with the Streamlit, it will give you a web-based output or UI user interface at the end. So let me do the same here. So I just need to move back to the session 3. Session 3, and then install the requirements. So these requirements are the required library to run this section. So, and the next step is creating the .m file. So look, if I go to session file, so there is no .m, so there is .m example. I'm going to replicate it in the new file, and then here, copy the right token, the university one, and the Google you already created. So simply, I can copy from the previous one, completely copy them all, and paste it here, and save. So going back to the README, first I'm going to run the terminal version. And then I will load the Streamlit one, which is showing the same thing. So that's going to be very interesting here. Yeah, let me explain what's happening inside the code we already have. So what we did here in the RAG implementation, we create some knowledge base, right? And we're going to, as Hertfordshire said, the main purpose of RAG is removing hallucination. From the available data, we're going to retrieve useful information, right? Because if you just simply ask an LLM model a specific question, it will come up with different kind of answers. But if you limit the knowledge of the LLM, it will only respond to you based on the knowledge you already given to the LLM, which this knowledge named here is knowledge base. Okay, the knowledge base we provide is, for example, some information about robot arm, some information about the sensors, very brief. In reality, it's going to be huge corpus, huge database, huge information. Okay, gigabyte, terabyte information. Here we just, for example, we just put some very simple text. Okay, so these are the knowledge base, and what's happening is, so we're going to ask some example question. No, it's fine. And you will see the result of with and without RAG. So what's the difference here between with and without RAG? With RAG is more confidence. How you know that?
Without RAG is just a guess.
Yeah, it's just a guess. It's just
General.
Yeah, very general kind of. But with RAG, it just retrieve data from the available knowledge. Right.
Question, guys? Do you understand what's the main concept of the RAG?
Yes.
Okay, it's really important, and because, as I said, everything in the LLM is the prompt, so you should use the various type of the methods to enrich your prompt for your agent. The RAG is one of the things that help you, and the RAG and the MCP is really strong methods that you need to adopt in your agent. The RAG also can prevent the agent about a hallucination. That's really good. Maybe you see some picture in the LinkedIn that someone asked about the mushroom and the LGBT said, "Yeah, that's totally safe. You can eat that." But after eating that, it will die. And it was a hallucination. So the RAG can help the agent to understand this part of the problem because we will provide the LLM with the more accurate data. So it's really helpful. But let me ask a question. What's the difference between the RAG and the MCP? Any idea? What do you reckon, guys?
Give answers, updated answers.
Pardon?
Up-to-dated answers.
Yes, updating. Yes, definitely, that's correct. Because in the RAG, we have a static database, I can say. So the agent will use this outdated database. But the MCP, because it's connected to the internet, for example, it will provide the agent with the updated information. But we couldn't say, let's use the MCP instead of the RAG, because RAG is really faster and the agent will use the RAG as a main reference. So also, because we provided data for the RAG, we could say that the data, the quality of the data is accepted. It's the correct data. But about the MCP, we don't have any evaluation method to evaluate that this is the correct data or not. So as an AI engineer, when you want to build your agent, you should have a trade-off between these two tools to find out which one is the best for your use case, for your application. We could say, for example, RAG is the previous version of the MCP, so it's a deprecated method. No. We should find which one is good and based on the use case and the purpose. So question? Yep.
Is it correct to say that MCP connects LLM to that external data and RAG reads that external data?
Yes, that's totally correct. Well done.
We can use both.
Definitely, you should, to be honest, based on my experience, you should use both of them. And the RAG is for the helping the agent to know what's the limitation, and the MCP for inserting the new data to help the LLM to have a better reasoning system. Yep. Question? Okay. Let me see what's the next slide. So did you run the Streamlit, all of you? Did you test that?
Yeah.
Okay. So because all of you was interested in the pizza, I've designed this agent for you to help you to cook something. So the next agent that you want to work on that is the recipe agent. Using that, you can cook something for yourself at your home and can help you to be a very, very expert chef. So please try to run this code step by step together, and because you know currently you know what's the meaning of the MCP and all of the requirement that we need to have for building the agent, you should able to run it without any problem. And let's evaluate your finding today by running this agent step by step together. And please be careful to run that, because if you want to attend to the our final competition, you should use this agent. So please run it, all of you, and test it, change it, modify it, and everything.
So if you can, you can give it more detail. So what is exactly recipe agent and what it is going to do for us?
They can make a pizza for themselves, isn't it? Yeah.
Is
Yeah.
in the slides? Next slide, okay.
Because they are using the command to run that, yeah, just let's help them to run it, and then I will back to all of them to explain what's the agent. Please first of all run all the commands, and if you have any question, let us know. Me and my friends can help you. How many of you run the first script? So did you see the result? It shows that how many MCPs integrated with this one. Because LLM is not, for example, expert in all of the foods, for example, the Persian foods, Indian foods, I don't know, different things, we need to use the MCP to provide it with the more information about the different things. So these 4 MCPs will work for that because of this issue. And to inform you that we never use the online MCP. We use some JSON file to load it locally because of its speed and to show you how it work. So the first one just show you which MCP will work. If you go to the code, its source code, you can understand how the MCP will generate at the MCP server. Yeah. Question up to now? Question? No? Okay. So after that, let's run the second one. Yep. It just tests the MCP works or not, and using this sample prompt, it tests the MCP servers, and it says it's work. And the final, let's run the agent. So let's say, for example, pizza. There we go. Oops. There's a possible page. Oh, because we use the static data for cooking some things, the pasta was our sample. If you press enter, in this case, because the MCP has information about the pasta, if you work with that, as you can see, it has another error.
Look, what's we trying to do at the end of this today? We're going to come up with a chef robot challenge. Okay. So you remember first agent? The first agent was about a robot. Okay. We should come up with a design of agent to propose a robot configuration. Okay. So next step to create a robot chef is creating a recipe. Okay, based on the food you want to create. For example, in the default example, we're going to create, for example, pasta carbonara, for example. So you need to come up with an agent to propose you the method you're cooking, the ingredients, and so this agent completely is about this section. So this is the same MCP based agent with different tools.
So I found the problem. There was an ENV file. Yeah. Okay. So let me fix that and test it together again.
Yeah, just copy it from the previous.
There we go, it worked. Yeah, the problem was the ENV file. I didn't update that. So as you can see, in the JSONic style, it could find that what material it needs for cook the pasta. So you can develop this agent for yourself to help you to be so expert chef when you invite your girlfriend or boyfriend, I don't know, to help you to have a better time. So yeah, this is the last agent, and so let me explain what will happen shortly to summarize everything. We build an agent, we integrate it with MCP servers to get information, and also we have a rack system for that to help it to understand what's the main purpose of that. So when you send the name of the food, the agent will process that, and step by step it will help you to cook that. Question?
But we didn't get the cooking instructions.
Change your system prompt to find that, okay? And also, if you think it needs more information in this code, there is Reza, where is the rack system, the metadata of that in the code? Those MCP servers.
The embedded to the
This one?
Yeah, recipe MCP server.
Yeah.
Just scroll down.
Yeah, in this file, you can see the information that we provided. If you update this information, because it's an MCP or MCP server, so yeah, you can have a definitely better response. As I said, as a sample, we use this static data, and yeah. Other question? No? Yeah, this is all of the architecture diagram that will happen. User send its query, the LLM will receive that and will interact with the rack system if it has. And also based on the query, if it needs more information, it will call or trigger one of the MCP servers. MCP server will gather the information, return to the LLM. LLM will update the system prompt, and also at the final step, it will execute the system prompt to produce the result. That's all of the things that an agent needs to do. So if you want to have your agent, you should focus focus on each of these steps and enhance them, and yes, design one of them based on your use case and your purpose. If you can do that, you have everything. You have an agent. So if your agent is not accurate, you should enhance one of these steps. Yep, that's done. Question? Everything is clear? Yep. Okay, so I will hand it over to Abulfaz for the next session.
So guys, I hope you have a very clear understanding about the rack and MCP, the differences, how they can be employed in the integration. So you already have the sample code. Of course, we didn't ask you to write this code line by line. It's going to take some time, but you already have a small sample on the repository, so you can use AI by coding, to extend it to the one that you would like to use. So we implemented two simple agents at the moment, the robotics agent and the recipe agent, So we did two different tasks with these two agents. Now we are going to have a competition, like a challenge for you, to see if you are able to create a multi-agent system. So these agents are able to interact with each other and come up with a solution for the prompt that they are receiving. So you ask something, from the system that you'll be developing, and the system go and explore, use RAG, MCP, the agents interacting to each other, and come up with a solution. And the solution will be appearing in the Streamlit UI. So you are allowed, this is not the academic degree, so you are allowed to use whatever AI tools that you have. So we are planning to have two winners for the first place, two winners for the second place, and two winners for the third place. So which means that if you are assumed you are 50 here, so we have 6 prize. More than 10% of you will receive at the end. Okay, so not to you, I mean to the winner. Don't be happy. All right, so I ask you, Reza, to come to brief the challenge to you. All right, so since the challenge is about the multi-agent system, so Reza will brief you what is the multi-agent, will present you the structure of the multi-agent, and how can it be implemented. And then you can use this knowledge to implement your
Thank you so much.
Thank you.
So, first of all, make sure you all complete the first and second agent, right? So, the first agent was the robot agent. The second one was recipe agent. So now we're going to combine these two agents, right, to have a chef robot. So a chef robot needs to know what is a recipe. Based on the recipe, we're going to design a robot, right? So how should it work, you think? What should be the communication between agents? I mean, you come up first with a question about what you're going to cook, right? So your prompt is the dish you want to make. So what's happening? Can anyone explain any architecture in your mind? Louder. Share your knowledge, please. I mean, what? That's okay. So, I mean, we're going to design a robot chef, okay? So now we need to think about, I mean, we already have two agents, and based off these two available agents, we need to combine these two agents and create a robot chef. So how does the architecture should be like? So MCP is attached to agents, right? Agent 1 has its own requirement for the MCP. Agent 2. So
We have two agents.
yes.
Agent 1 will have that.
No, there's no rack. Both of them come with MCP, right?
We have a knowledge base of the steps on how to prepare different dishes.
In this case, no. If you want, you can create yours. But in this case, we have two simple agents, both using MCP. And there's no knowledge base. So first one need to come up with the first prompt. The first prompt is that what was the recipe? What was the process of the first agent? You were asking the agent to make you a dish, right? So the output will be, okay, I'm going to create this dish with this ingredient and blah, blah. So what you're going to do with the output of the first agent? Feed it to the second agent, right? So based on the information provided by first agent, you're going to prompt the second agent. And second agent tell you, okay, I need this robot with these sensors components to be able to create this dish for you. Okay, you're designing a robot chef platform at the end. So good. So yeah, the architecture would be something like this. The user comes with, for example, a prompt. I need to cook a pasta. And agent 1 comes with reasoning, some consideration about safety, about the way they're cooking, the tools. And the next step is the output of the first agent feed to the second agent and come up with the proposed robotic platform at the end, based on, again, the available robots or platforms. So here is also the description about this. So any question about this slide? Say again? What is the end goal? At the end, so you'll see in the Streamlit. At the end, you come up with a proposed solution about your robot chef. I mean, which platform you need for this, how it should be cooked, safety, tools, whatever you need. We'll see. So the technology we are using, we're supposed to use, is MCP. agent-to-agent protocol. It can be very simple message passing. Doesn't need to be a specific protocol for now. So that's all. Yes?
Is it sequential way or is it like a functional way of handling the...
It's just flow. First and then second. There's no loop inside.
Is there any agent undergoes in...
No. There is no agent orchestrating these things. No. First and then decide, and then second, again, separately. No. Yes. So what we need to do, go to the session 5 now and set up the environment, install your libraries, the same process. Same process, and so it's going to be your last environment setup. So try to enjoy it. So yeah, then we're going to run this Streamlit app. So let me do it at the same time while you are trying. Any question? No. Okay, session 5. Okay, what we need to do, simply follow the README. Session 5, install the requirements. Okay. There's no requirements? Yeah, because we already satisfied all requirements. We don't have, no, we should have. There is requirements. Oh, the T is missing. Right. And then you need to set up the environment to set up the token keys. So now we have this this is from the previous section. Just simply Control A, Control C, going back to the session 5, and then set up Control A, Control V, and you update the token for both. One more tip about this section is the way we designed this code is initially the user will use the local. If you set up the local token, initially it will try to use the local LLM which we created in university cluster. If it's not available, it will fall back to the Gemini model. Okay, so if you want to use directly use the Gemini, you can comment, for example, this one, and then if you run your code, it will automatically go to your Gemini. Or if you want to only use this, so you just need to set up this one, first one properly. So I will try with both model, and will show you how does it work. Okay, so we might face some problems, some errors with different models. Let's see how will it work. So set up the environment for session 5, and now running the Streamlit app. Okay, so this one will run on the university, a local LLM, which is a QM model, 32 billion, I think, parameter model. So I'm going to, for example, make pizza, right? So it try to, first the agent 1 try to come with the solution, and the agent 2, but you see, my model got an error because this model is not good enough or big enough to provide a good answer for these 2 agents. So what I need to do, I need to change my model. So that is very tricky sometimes. So you need to select the right model for your task. So I'm going to disable the first one and connect to the Gemini using Gemini 2.5 Flash Lite version of the model. So, and then run this again, see what would be the result. For the first one, the model failed, but hopefully with this one, it will work. Yeah, you can see, yeah, we have a typo. It also understands. I wrote the wrong name as a pizza, but it could manage to, it couldn't manage to. So let's see. Oh, I failed again. So let's say pasta, maybe. It's not good at pizza. So let's check out the, look, for me, both model got failed. Doesn't come with a good model. I'm trying to change my model from light to normal model. Maybe it will work this time. I'm not sure. Oh, that's a problem. Because, yeah, I need to stop my code and run it again. That's my problem. So let's keep it the same. I need to stop the code, Streamlit, and then run it again. Because if you change the config file, it doesn't load the file. Again? It's okay. Yeah, I mean, if you do the change to your config file, you need to stop Streamlit and run it again. Yeah, now we got the complete result. See, so it says pasta is too general. Could you please specify? So okay, let's say pasta, or say, what kind of pasta do you like? Margarita? Margarita? Really? Yeah, we can play around with the. So, it's not recognized because it's not in the available, database. I think pasta carbonara is the available. I have a typo from writing. Is it correct? See? This one, it's okay. It just show the error if you disable the first one. Looks this time, yeah. Good. Okay, finally.
If you could
zoom in. Sure. So what we have, because it seems the get a specific, okay. I want to enable to retrieve this video. Sure.
The online people are saying the sound is.
Oh, I
yeah,
see.
I'm
Okay.
checking the microphone now. Hopefully that's fine now. Yeah. So and then, yeah, that's good. Thank you.
Yeah. So let's look at the result. We need to check. Look, someone asked me what would be the output, the outcome. So that is the outcome of Agent 2, which is the final result. Which is, the robot design overview. So we need to come up with different settings to set up. I mean, this is very detailed, actually, design, honestly. Okay, try to do it yourself and see the difference and see your result separately, and we can discuss. Yeah, it's a complete design of a 7DOF manipulator and some optional, actually. So what it decided to come up with a 7DOF collaborator arm. It means it can be 2 arms with a payload of 5 kilograms, with being able to reach to 1.1 meters, and the precision and repeatability of 0.05 millimeter. Does it really need that precision? Degree of freedom, and so on. So this is the design based on the information we gave to the model, right, to the agent. So you see, when I asked to create different dish, so it get refused because it wasn't in its knowledge or tools we provided. So we have some limited options. So if I go back to the PowerPoint, you see here we didn't mention, but here we mentioned the number of dish we can make.
Have we finished with the...
Almost, yeah. If they finish, I'm finished. Because my side is almost done.
Yeah, thank you very much, Reza, for your presentation. So that's a great example. So guys, you know how important it is to develop something like this and upload it on your GitHub. Yeah, you can't believe how it's important for your, when you're applying for a job. If you develop some sort of this system, you upload it on your GitHub. It's very important to show that it's showing your knowledge and the skills in the domain, right? All right, so that's the working example and of the agent, right? And as I said, you can get this example, enhance it, extend it and you reuse it for different purposes for using AI, right? That would be easy, right? Okay, so that was an example of multi-agent. So you are now more familiar with the multi-agent systems and the role of the LLM in the development of the multi-agent system, right? So we expect to have a coffee break at 3:30. It's less than 1 hour. So now we are going to introduce the challenge to you and also to the online students that attended online, yeah. And you will start working on the challenge problem. And once you implement it, you will upload it through the form that we will share the link, yeah? You will submit the text file for a Word file, actually. You copy and paste your code into the Word file, and also we will provide the prompts in which you can send to the developed system, because you have to use the identical prompt, and you just simply copy and paste the output of your system, attach it to the code, and send it to us. We will evaluate all of them, yeah. We will tell you which one works with the higher performance, yeah. Okay. So, but first of all, I'll give you 5 minutes to wrap up with the multi-agent things. If you haven't done yet on the Python, I see some of you still working on Python. And then we will introduce you the challenge, yeah? I'll now switch to the challenge slides. That is about the multi-agent system. So you will use the Streamlit that you learn about to design the AI, agent 1, agent 2 with a specific task, yeah, and then user entry and the whole implementation. Okay. So I give you 5 minutes to wrap up, and then we will start the experiment challenge. Yeah. I'll give you 5 minutes to wrap up, and then we start the challenge. All right, guys, so that's the challenge time. So Reza is going to give you a brief of the challenge. First of all, you need to understand the task that you need to implement, yeah? And understand it clearly and then start doing the challenge. Yeah.
Yes, thank you very much. So it's almost similar about the challenge, about what we already did. So the same architecture, 2 agents, and 1 request, and the output going to be a Streamlit output result. But the difference here is we're going to come up with some specific request. Okay, for example, we're going to limit the cost of the dish. For example, we're going to say, cook a dish for me with limited amount of, for example, but with 15 pounds or 10 pounds, a specific amount. Or with a specific amount of nutritions, like high protein, low protein, low carb, high carb, or a specific diet, right? So we're going to make it more specific in the challenge, right? And yeah, that's the main actually problem you're going to solve in the challenge. And the same thing's happening. Agent 1 come up with the recipe, like how the process of the creating the food, making the food happening, and Agent 2 come up with the robot design. You can keep the agent do the same and do apply your change in the first agent. So I will give you the specific prompt, input prompt. You will have 2 prompts for your input, and we will analyze the output of your agents, both agents, agent 1 and agent 2. Based on the output of your agents, we can decide, okay, whether you provide the proper answer or not. Okay, so I will explain it. So you're going to have a limited budget, serving food for 2 people, and the nutritional targets is specified. And again, agent 1 pick a dish, and agent 1 explain the trade-off. So mainly your task is working on agent 1, and the output will pass to the agent 2, which is designing the robot. So let's see. So what you need to do technically is extend the dish database by adding price, the protein, for example, calories, vitamins, or per dish. I mean, these details need to be added to your database. You can hard code it as it is available in your code base. You need to add a new MCP tools to agent 1, update the agent 1 system prompt, and update the Streamlit UI to show the output at the end. So yeah, you have. I mean, the basic of your code is the same, but you need to apply this change. So the judging criteria is based on the balance quality, the reasoning, UI usability, and code quality. You have some bonus points if you come up with some dietary filters, shopping list quantities, and multiple meal suggestion. Yeah, do you want to add something?
No, that's clear.
Okay.
So if it's clear for you or not. If it's not, just tell us. Yeah, we explain again. It's not clear. What does it mean? Not clear.
Okay, let me try to clear it by the last slide. So look, the input for your model would be both of these prompts. Okay, so but your output will be different based on your design. Okay, maybe I'm going to design in a different way, and my design come up with different answer of yours. Okay, but we're going to evaluate your work based on these 2 prompts, and the 2 prompts referring to, for example, so see, instead of just saying I need to cook pasta carbonara, I'm going to say I have, for example, 12 pounds for 2 people, and we need high protein meal. Design a robot to cook it for me, right? The second prompt is saying, okay, I have, for example, 20-pound budget, 2 people, 1 person is vegetarian, plan a balanced meal plus a robot design.
Yeah, I think, yeah, that's good. But I think what is not clear for some of you, I believe, this is the way that you can test your final implementation, yeah? But what you need to implement, yeah? This is not clear for some.
I mean, yeah, but what they need to implement, again, there are some points, considering the price, considering the nutritional. I mean, these are some tools you need to add to your MCP. Okay, we don't have a price, for example, tools in MCP. We don't have nutritional evaluation in your MCP. So these 2 tools, or dietary, 3 tools, or any other tools, need to be added to your agent. So that's the main challenge. Some points you need to run each prompts. I mean, these 2 prompts I already mentioned. I think you already pushed the code from GitHub. I would suggest to fork the, I mean, fork means, do we have a GitHub here?
Yeah.
Okay.
I think it's already open.
Which?
Should be somewhere.
Here.
Isn't?
No.
No, isn't the third one?
This one?
No, it's Streamlit. Oh, yeah,
This is Streamlit.
You just type GitHub.
GitHub.
So guys, if I were you, yeah, let me guide you, yeah? You have 3 slides altogether regarding the challenge. If I were you, so I upload this into the GPT and ask, okay, this is our challenge, yeah? So what does it mean? How to start implementing it, yeah? And aside from that point, reuse our material that we provided and come up with something, yeah? This is a creative thing. It's not considered as cheating, don't worry. Because this is not the exam, yeah, this is a challenge. We assume you are at home, yeah? We have some online people taking this challenge. So the output are different depending on the, for example, if you say the temperature factor of your LLM is this one. No, it's a text file. It's like a 1 paragraph, yeah.
So do we have to add new recipes?
Yeah, we are saying, okay, you have to say we are going to cook this food for 2 people. The overall cost could be, for example, 20 pounds.
Yeah, but we try to limit it. We have only, if I show you, some specific food, maybe 10 dishes or 9 dishes. We have.
We already have.
Yeah, we have some, but
so we
need
limit
to, yeah, you need to add some details, right? Like price,
To
like
the same.
ingredients, yes.
To the same, or we can add
To the
new
same,
recipes.
yes, to the same.
If you have any questions about the slides, I just shared the 4 slides related to the challenge on our YouTube live. And if you have any questions about any of them, you can check it from there.
Yes. Thing is, I want to show you how to fork the repository. Where is it? Yeah. So, I mean, forking repository means you are copying the same code, but in parallel. Whatever you change, you do, progressing in parallel, and at the end, you can push your fork, and we can have access to your code at the end. So that's the wise method we can have access to the code. So just need to click on fork, and the code repository will be forked in your local GitHub environment. So you can change the name, or you can keep the same name. And so what's happening is, if you see, this is the original repository, After forking, it's going to your domain, to your GitHub space. So the same project, but in your GitHub space. So from this point, you can develop, you can change the code, and at the end, you can share this code, or you can push to the main repository, which is the workshop repository. So any question so far? So good. So yes, if you want to get access to 4 slides at the same time, you can go to the YouTube channel and see all slides at the same time. And these are available here for review. So I'm going to extend this, keep it here for you, and let me know if you have any questions.
شیر نمیکنم.
ما شعرش صداش کم صداش کم
کنسل
نشید خیلی
نشد پلی نمیشه. نه
برای یوتیوب Okay, guys, are we ready? Yes. So we have three types of awards. Yeah. So the golden awards, silver awards, bronze awards. Yeah. Ideally, we normally give 3 awards per everyone. But for this cohort, since it is a large cohort, yeah, we decided to give 2 awards for the gold award, 2 silver award, and 2 bronze awards. Let's start with the third place first. All right, so is the name of the third place. You should come here, yeah, and so the third award goes to the student name. Let's see. Should be magical, yeah.
It might be not working.
Maybe internet is running low.
Yeah.
Firewall issues.
Yeah, who is this? Who is this? Yeah, come please. So you get the first award. Congratulations. Yeah, just wait here. Yeah, the third award, one of them goes to you, and the second, third award goes to the.
Let's take a photo of this.
Yeah, sure.
Ali will help us. Yeah, we are waiting for the photo and then we will go to that. Did you update the name? You didn't? Yeah, that's it.
All right, yeah. Yeah, congratulations. So this is for you, the Amazon Water. Yeah. Yeah, thank you very much. You can sit. All right, well done.
Going to the slide, yeah?
The next one goes to the. Hold your press. No, sir. Who is it? Come in, well done. Well done. Congratulations. This is for you. Take a picture. Yeah, come in. Yeah, well done. All right. So let's move to the second prize. Yeah.
Can I go to? You didn't update it, yeah? It's a fun. Okay.
Okay. The first, yeah, Basit Malik. Who is it? Thank you very much.
Okay.
So he's not here, but take a picture, please, Anton. Yeah, thank you. If he's around, just ask. He's on the bus, maybe. Yeah?
He's here.
Okay. Yeah, okay.
Let's wait.
Okay. So, okay, let's wait for Malik.
No. Sorry.
Timing.
Okay, just sorry about it. Sorry, guys. No, we are in the call with him.
Yeah, we can wait a little bit, yeah.
On the what?
Is he coming here? Okay, that's fine.
See him run. You didn't expect.
Yeah. Okay, okay. All right. So we will issue the certificate of attendance to this workshop and email all of you, yeah, one by one.
Where
And
can we
then
access
the pictures. So I'll post all of the pictures on LinkedIn, yeah, that's the easiest way, right? So you can reshare or download or whatever.
And also, it will be available in our website as well.
Yeah, he's the.
Are you Malik? I'll take picture. Congratulations, yeah. You are in the second place prize. Okay, so go take your boss. Okay, thank you. So, okay, let's move on to the, we have 3 more. Second place of the award goes to the, who is it? Come here. Yeah, well done. Congratulations.
Go for a party after this.
Thank you. Thank you very much. Yeah. All right, and the first place, the golden prize, the first one goes to finally, yeah? Congratulations, yeah? There you go.
Can you take the photo?
Good? Okay, thank you. That's it. Don't share with it, yeah? All right, guys, and the last one of the first place goes to the Ashir Ahmed. Oh, that was interesting. I tell you the story about this guy. So last night at 12 o'clock, 12 a.m., this guy contacted me on LinkedIn, say, yeah, you tell them.
Okay, so my friend Basit, he texted me on WhatsApp.
Yeah.
And that we are having an event. So I was like, I'm living on campus and I should come.
Yeah, okay.
Then I searched for the YouTube channel. I saw your name, A. something Zaraki. I searched on Google. I found your LinkedIn and I texted you.
Yeah, well done. Yeah, I mean, he texted me at 12 o'clock. I was working on these slides. I said, okay, no problem. Just come, and if you find a place to sit, yeah, feel free to come.
Thank you.
And this is a lucky guy, I guess.
Thank you.
Sorry. Okay. Take picture.
Wait. Take it with it.
Thank you.
All right, thank you.
That's it.
All right, thank you very much, everyone, for attending this workshop. I hope you enjoyed. We try to repeat this kind of workshop based on the comment that we receive on the form that you fill up. We're trying to enhance. That's a lot of work, but it pays off when I see you smiling and you feel learning something new. Yeah, thanks a lot. Yeah, can we can have a group picture if you want. پوستر بزنم زدم هم منتیش زدم هم پوستر آره آقا عکس ورکشاپ رو بذار عکسای 4 نفر خودمون بذارم بالا 5 نفر اسلاید اول yeah, come, guys, come here. Yeah, here, we take a picture, yeah, that's all. Yeah, if you wait, these guys are taking a picture from themselves. Come together, yeah, that's a group picture. Come, yeah, anywhere, don't worry.
We can sit here?
No, you can, yeah.
Sorry.
Right?
So he's going to take a picture. Okay. Okay, excellent.
Some of the students can stay there and we can take a photo from that side.
Yeah.
You can
If
stay there.
one of
yeah,
Ali's.
Yeah.
You guys can squeeze around.
No. In this row, if you can. Yeah, just come in this row. Just careful about the laptop. David, you can stay there as well.
Ali, I think you can step on the.
Yeah, I need to sit down. You guys need to sit down.
Say cheese.
Cheese.
You want to come?
Ali, yeah, come please.
Yeah, if you can
someone
take a picture from us.
Ali Binci. Ne Binci?
Sorry.
Sorry. Cheese. All right, thank you. Thank you, everyone. And see you around next week, maybe. All right, thank you. Yeah, sure. Yeah, of course. We will.
Oh, your name. Yeah, sure. Which one was it? The first place. Second first place, yeah. Okay.
Thank you so much for this opportunity.
All right, thank you.
See you.
I'll be in connecting you. Call you back.
Yeah, see you.
Thank you. So they can access the photos during the website, by the website.
Yeah, we will send you the website.